Testing 1 2 3. Testing audio 1 2 3. Testing audio 1 2 3. Testing. Testing audio 1 2 3. Testing audio 1 2 3. How does it sound? Testing 1 2 3. Testing audio 1 2 3. Testing audio 1 2 3. How does it sound? Testing 1 2 3. Testing audio 1 2 3. Testing audio 1 2 3. How does it sound? Testing 1 2 3. One, two, three, testing audio, 1 2 3. Testing audio 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 1 2 3. Testing. Testing audio 1 2 3. Testing audio 1 2 3. Testing again. All right. Testing 1 2 3. Testing 1 2 3. Testing. Hey everybody, how you doing? It's me, Aaron, the Custodo. It's a Tuesday afternoon if you're watching in live, or if you're watching on video recording. It's the 12th of September. Let me get rid of this cough drop 1 second here. I am about 80%. I apologize for not streaming for a while. It's been a hot while since I streamed. I was on vacation, and throughout the arc of going on vacation, I got sick. That's never fun, right? So had a sinus and ear infection, couldn't hear, all those kind of bad things. And then I flew for like, let's see, 16, well, flight from London was like 9 hours. The flight from Prague to London was another 3. Flew for basically about 16 hours one day, and over a day and a half period of time. And boy, that really don't fly with an ear infection. It hurts a lot, it turns out. But I got got back home here to the U.S., got some shots in the butt, and boy, they really help. And feeling about 80% now, enough to do some streaming, write some code. So I've got to update the stream information because the repo it links to is wrong. Working on a new project here, folks. In the past, I was working on another, just an example, but this is a little bit closer to my heart. I worked at several different accounting firms throughout my career, and then I've also worked at a hospital. And one of the things that was really important to them was inventory management. And specifically at hospitals, it's kind of weird. It turns out that one of the problems we ran into is trying to figure out like why we were losing so much money on stuff. I mean, hospitals charge people an arm and a leg here in the U.S. for stuff like, you know, a Band-Aid or even like ibuprofen costs like a lot of money. So it's like, why is this happening then, right? Why are we losing money on this stuff? Well, it turns out some genius at the hospital that I worked at decided to buy everything in bulk. And they said they were going to save all this money by buying in bulk. Well, what you forget about in a hospital is that most things expire. So if you buy too much, you just throw it away in bulk. So if you buy like 1,000 ibuprofens, but they expire and you have to throw away 90% of them because you have to buy new ones because the old ones have expired, then you're not really saving any cash now, are you? Now, how did they find this out? Well, they found this out because I was part of something called a lean process at the time, and we started evaluating the data to look at, try to figure out like why we were losing money on this. Now, it turns out the answer is to this very interesting story is it wasn't the data that showed us that we were throwing out the stuff that figured this out. It was the nurses working overtime. We couldn't figure out why. We did this whole system that I wrote back in the day, this data platform. We were trying to calculate, we were trying to guess how many patients would be in the hospital. We looked at all the analytics of the prior years, and we could actually calculate with pretty good statistics, like this many patients would be in the hospital for the month of March of 2023. And we could look at the last 5 years, and we could look at even demographics of age. And that really helped us to know how much staff we need. But that also told us like what kind of things we should have in inventory. But what we couldn't figure out is that this hospital is in Michigan, and a lot of people goes to the south for the winter. And so it was actually February that this month came up that we would have these nurses working overtime, but there's no patients in the hospital. And it made no sense to us. We're like, wait a minute, why are we paying overtime to nurses when there's no patients in the hospital? Well, it turns out we didn't know the answer to that, so I went down to the floor eventually, asked the nurses. I'm like, hey, there's either two things going on here. Either my data is, you know, the scripts and the SQL statements and all the code that I wrote was wrong, or nurses were working overtime. They're like, no, we are calling nurses in. I'm like, but the floor is dead. There's nobody here. They're like, yes, but we're doing inventory. And I was like, why are you doing inventory? And then they explained to me that they throw out stuff all the time. And I was like, wait, what? And then we started going into that deeper and found out, oh, geez, this is terrible. So it turns out inventory is important to just about every company. Regardless if you're a bunch of coders, you still have assets that you own, things like laptops that you have to depreciate over time so you can buy a new one, you can write them off on your taxes. That's how the tax system works. Like I said, I used to work for an accounting firm, so I know way more about inventory and all this kind of stuff than probably the average developer. So what am I writing today? I'm writing an inventory system that would be used to run on a iOS device, like a tablet or a phone, or even your Mac, for example. And it would run on all three of those platforms, no problem. And it allows people to track inventory based on warehouses. So we're going to say in this glorious example of this universe is that there's a company and they have warehouses straddled like 13 locations across the U.S. And people go there and see what they have in the warehouse every now and then to make sure that what they have in their accounting system matches what's in the warehouse. It turns out that these pieces of data don't always match. More than anything else, a lot of times companies have to depreciate something because it died in the warehouse. I'll give you an example. Like, say, for example, you have you're a beer distributor. Okay, so you have beer in your warehouse. That's all you have is cases and cases of beer. They're in patlets all over the place. And somebody drives a forklift through one of the patlets of beer. It turns out you have inventory for that, but that inventory you cannot sell because the forklift destroyed it. So in that world, you would have to write that beer off. And when somebody went to count that beer, they'd say, well, geez, what's up with this patlet of beer that's been, crushed and stuff? Obviously, we can't sell this stuff. And they'd say, yeah, we drove a forklift through it. And so we'd have to depreciate that, write it off, is a loss, and et cetera, et cetera. So this inventory app is going to do that. Now, in the prior streams, I was not doing this for reals, and I'm doing it for real now. And what do I mean by the word reals? Well, I was just kind of fiddling around with some UI stuff and wasn't really writing the code in the way I'd normally write if I was getting paid to write it. Now I'm actually doing this like if I was getting paid. Like, this is like, realistically, this is how I develop as a real developer. So this is gonna be kind of interesting. So you're gonna see here, I'm gonna run this app, and you're gonna see that nothing happens. You're like, well, wait a minute, Aaron, this app doesn't do anything. In fact, if it launches, let me get it over here on the stream so you can see, it just says hello world. It doesn't do anything. What the heck, Aaron? What gives? I thought you said you're building on an app. I am building on an app. However, I write tests first. I write a lot of tests first. In fact, if you take a look here, I've got all these tests up and running, and I know that there's certain parts of the application now that work. I can't build. So the problem comes is that when I build apps, a lot of times I need data to show on my screen, right? To show on the app. And without data, can't really do that. Now, some people, they'll build something called mocks, and that's perfectly fine. You can build a bunch of mock stuff to go through and test your code to make sure your code works right. However, I'm using Couchbase Lite, which is an embedded database platform, which means I don't have to write mocks. I can write real tests that go against the real database, since the database is embedded into the app. And we would call these, technically speaking, integration tests. If you're getting into the nitty-gritty of the computer science terms of how this works. But I've written some tests, and so that's what I'm going to do today is I'm going to continue writing tests. So what kind of tests do I have so far? That's a good question. Let's review what we have right now. We've got tests broken down. If we're going to take a look at our tests here, we've got some authentication services that we're doing, and we have a mock authentication service right now because I don't have any real authentication service set up. So there would be, you'll see here I have a interface, or what we call protocols in Swift, same thing as an interface in Java or .NET. And you can see here that I have a mock version of that is used to authenticate some mock users that I have. And I'll probably change those users out here in a little bit. But for right now, they're serving the purpose of passing my tests to make sure my code works. And then you'll see here I have a database manager test that tests to make sure that the database actually starts itself up, and it goes through and tests to make sure that we can do all the things that a database should be able to do, including it makes indexes for all my queries and make sure that those are going to work. It goes through, it sets up all the files and makes sure that all that good stuff works. Now, I have something called a base test. And this is something that is a cool thing to learn. A base test allows me to write a base teardown with errors function. So every single time I use the database, I need to do a certain amount of things. I need to set up a user. I need to authenticate that user in. Then I need to get the user. Then I need to tell the database manager, get me the database for this user, because we're going to allow multiple people to be able to share this. Hey, Cactus, how you doing, buddy? Welcome to the stream. Haven't seen you in a while. Glad to be back streaming. Hope you're having a great day today. So in this test, I've made something called an abstract. Well, it's not an abstract class, but it's pretty close to that. In a sense that I've got this boilercode that all my tests need. That I want all these tests to use this stuff. And so I've written this base class here, this base test class, that just goes through and sets up everything for me so that I can feel good about everything, okay? And then what ends up happening is that all my different test classes just inherit from this thing. And I'm going to abuse the rules of inheritance then so that I don't have to write that anymore. That code that goes through and sets up my mobile database and stuff, that's all just right here, this teardown with errors. It guarantees that when the test is done, it will clean the palette and guarantee that my databases all get deleted so that when the next test runs, it can start all over again. We want a clean system for every test that we run. We don't want another test to dirty the data so that when our next test runs, our test may fail because of the fact that the data is not set to a same state. And so for each test that runs, we want the state to be, I don't have anything, and I'm testing the universe here. So I've already got a bunch of tests written here, and we're going to continue on the world of writing some tests before we start writing some UI. This is how I normally build applications, to tell you the truth. I almost always have the data and some tests laying around that test that before I even start writing UI. Because I don't want to have the argument of like, do I have the data I need? What is the screen going to look like? I mean, honestly, if I'm doing this for a living, and this is a real production application, I would almost always have the mocks ahead of time. So it's somebody give me like a Figma or a Sketch file. It used to be Sketch. I guess Figma's getting more popular these days. I still prefer Sketch myself. But Sketch is a competitor to Figma. Came out before Figma, and Figma's more of a... I think it's gotten popular because of its multi-platform. It can run on Windows and also Mac. And so that I think people like it. And you can get it in a web browser too, I guess. But I still believe Sketch is pretty cool. And I would normally get a Sketch or a Figma mock-up of it, and then I would basically get access to either the data set or the APIs that I'm going to use in my mobile app. And then I could use those two things to start stubbing together the app, basically. And usually I'd start with data. I'd get all my data in there. I'd know that all my tests pass, so all my data is cool, whether it's a REST API I'm calling or, in this example, using an embedded database. And now that I know that, then I'm just free to go through and do cool things with the UI. Then I've got the whole thing lifted up. I know everything works. I don't have to go, is it my data that's broken? Or is it the UI that I've just written that's broken? You know, when you're trying to piecemeal things together, that kind of, where you're writing the data access code at the same time you're writing UI, you just don't know where your error is anymore. And that basically sucks. When you're trying to troubleshoot, it's not fun. So my answer to how I solve this problem is I write tests, and I guarantee that I know that my data code works, so that if my UI doesn't render properly, I know it's something between the data code that I know works and my UI, which means, you know, now I just have to go through and check, is it like a view model? Is it, you know, something within state that's causing this to happen? You know, whatever that reason is, I can go through and fix it much faster. So having tests are a good thing. Just code with no errors, geez. Yeah, I know. I wish I could live in this world. It's usually easier when you're working by yourself, to tell you the truth. But when you work on a team of like 5 or 6 developers, and that's, I would say the borderline for like having too many developers on a mobile project is about 4, in my opinion. I've worked with 5 before on really, really big mobile projects, but you start to step on each other's toes. And so that's where tests even come back, even help you more. So we're going to do that, though. We're going to just write some tests here, get used to writing some integration tests, make sure our data works the way that we think it works, and then we can start going through and looking at some cool UI stuff to do. So I've got a count method here that goes through and does work. And I usually run like this, to tell you the truth. This is real, like, I'm no longer on my test laptop. In the past streams I was using the Xcode beta. I'm still using the beta, but I'm on my real Mac Studio right now using this. So this is realistically how the Xcode, of course, this is a much smaller window because I'm streaming. I'd normally have this blown up a lot more, but I usually have multiple code windows open at the same time. And usually it'll be like an interface, or we call protocols in Swift, and the implementation. Or in this example here, I'll also have the tests open in the repository. So I'll keep like the tests open over here, so I can see here's my test that I'm writing, and then here's the implementation. And by doing this, I can go back forth and look at things. So that really helps a lot of times when you're trying to code. So it's a cool workflow to have. Usually I'll get rid of the middle parts once I have the code, the left bar there, and I code like this a lot. So I know that I need the ability to get the warehouses back that are in the database. I just want to get all the damn warehouses. I don't really care where the warehouses are at. I just know I want them. And I want to see all of them regardless. Now I'm going to make two functions for this. One, I want to get all the warehouses back. I want a screen that shows all the warehouses. But then I also want to be able to filter the warehouses by city, or probably city to start with is probably the best, and probably also state maybe. But we'll start with city, and that's a pretty good filter to have, right? Where we can write a query that basically says, hey, give me all the warehouses that are, actually state's probably easier because if there's multiple warehouses in that state, usually there's one per state, I think, in this data set. But either way, we'll write multiple queries then. We'll write one that basically does that query, that looks it up, just gives me all of them, and another one we'll write that just gets one of them. So let's see here. Let's start out with by saying that we need a function to do this, right? So if we look here, we can kind of cheese out here a little bit. We've already got this count function, and that kind of works. It's a good example of how to get ourselves started. Now, let's go ahead and say that we then, we should have a class called a warehouse, if I remember right. Let me go ahead and take a look at my data here. So real quickly here, I'm going to go back to my folder here, list, and go look at warehouses. I do have a warehouse. It's codable. It's got an ID, a name, an address, a city, a state, postal code, all the things we care about, longitude and latitude. That's exactly what I want to get back. So I know I want probably an array of these, right? So let's go ahead and then start out that by saying we're going to make a function. We're going to call this get, and it's going to be async. We're going to try to use some modern async stuff, and we wanted an array of warehouses. That seems like it's good. And then let's go ahead and go here. Now, this is going to get kind of interesting here. Let's see here. We need to return. Oh, we don't care about this. It's just saying, hey, I don't have anything to return yet, right? We've got some threading stuff going on here. Why are we running threading? To start out with, why do I need to do this task background and weak self and all this kind of stuff? It's a good question. It's performance reasons. So the database is embedded into the application, and we don't want the database running queries on the main thread because they could take a few seconds, and that's going to pause the ability for the user to do anything in the UI. And that is super annoying to the user. It really is. On top of that, it can get kind of dangerous if the phone locks up and they get a call, right? And you're on the main thread, fluttering yourself around and stuff. This just can build really bad experiences. So my answer is I never pull data on the main thread. I always pull it on the background thread. Now, in Swift, there's a couple different ways we could solve this, but I want to guarantee that this is, hey, how you doing? Welcome to chat. First time, let me give you a follow here. First time chatter. How you doing? My name's Aaron. We're in here writing some Swift code. Right now we're about to write some queries to look for some data. We're just talking about threading and stuff. Let me see if I can get rid of this. I don't want to know why is this happening. Oh, Streamlabs is being a jerk. There we go. Oh, I'm glad to hear you're doing all right. I mean, so I'm actually using Couchbase Lite, which is kind of, it's neither one of those actually. It's nor core data nor Swift data. However, the backend engine actually is the same thing, technically speaking. Core data and Swift data both use something called SQLite as their backend. And Couchbase Lite is a document database that also uses SQLite for what we call a storage engine. But it's got a layer in between that called Fleece that allows it to serialize JSON documents. So the way I look at this is that it gives me the power of JSON, which is what we usually get from REST APIs and stuff. And I can store that data in JSON, and I can just serialize it down and I don't have to learn anything about relationship databases and stuff. But it still gives me the power and speed of something like core data or Swift. The Swift data. The other advantage is that I get replication for free, which means I can just write 2 lines of code. This will go to a server and sync all the data on a big server out in the cloud somewhere to my mobile app and back and forth. And I don't have to do any work. I don't have to even check if the network's available. All that magic stuff happens for free. It's kind of nice. So that's what I'm going to be using in this. Yeah, it's a cool database platform. It's I mean, all of these database platforms, no matter what you use, they're going to always have advantages and disadvantages, right? And you have to kind of, as a developer, then figure out, is this what I want to use or need to use? Does this solve the business requirements? It's a big popular like Pepsi, UPS, one of the Dish Network, I think Dish Network or DirecTV uses it pretty big. Cruise ships use it because, of course, they need offline databases. Big companies like that, you end up using it for primarily for offline database, but there's a couple other tricks it has up its sleeve that also makes it kind of nice. So, but the gist of it is, it doesn't really matter if you're pulling REST data, you're pulling database data. You should really be thinking about threading a lot inside of Swift. If you're using mobile databases specifically, you have yet another problem with most of these databases, and this we'll get into a little bit later. But you have to think about your rights. So when we do queuing, right, if we were to look at Grand Central Dispatch is a queuing system, which means when you run work on it asynchronously, you can't guarantee that the thread is going to be the same. And in mobile databases specifically, at least for any mobile database I've worked on, you must always guarantee that the writes are on the same thread. And so that's the reason why we're splitting up a new task, is to get a thread on the background specifically, and so that we can have a better chance of controlling the performance of this. To guarantee that we don't lock the UI by running this on the main thread or on a queue. Most people don't realize the word async does not mean new thread. Also, queues do not guarantee new thread either. There's something called quality of service, and usually that is how you try to get a queue onto a separate, but you can't even guarantee they all run in the same thread. Threading is hard, it turns out. In other languages, you can make like a pointer to a thread. This is not equivalent. There's actually some different code I'd write if I wanted to get a true guaranteed to be in the same thread, which we'll do in a little bit here. But for reading, I really don't care as long as it's on a background thread. And it turns out in Couchbase Lite, you can read, and you can have multiple databases open if you want. I shouldn't say multiple databases, multiple instances of the same file open. And that actually can improve performance quite a bit. Hey, so yeah, it's correct. Async doesn't guarantee any thread. So if you want to guarantee not using the main thread, well, so the priority of background should give the guarantee. Because the priority of background should tell, at least according to the API, that this, not quite, really. So explain to me then, so we've got some things here going on here. Task with the parent's actor. But if you tell the priority of background, then it doesn't matter what the parent actor is. It should pop to the background. Well, at least that's when I looked at the Swift docs. Let's take a look at this. Let's see here. So we're having a conversation about threads. Actors is a... No, not necessarily. Actors is a Swift language feature. Yes, correct. It's more about understanding how threading works within Swift and keeping threads in sync. Is in each language this is done really differently. Like in C#, this is pretty easy. That's the language I have the most experience outside of Swift. Actually, I would even say I have more experience in Object-C than I do Swift. I'd say it's definitely, if I look at my experience, C#, Java, JavaScript, and then Object-C. I did that for years, and then obviously Swift kind of changed over. So I'm just looking here because like in Mac, I could do an NS thread, and that would be really easy to just do a thread like that. But my understanding is Swift, you can't do that. Yes, Swift is quite different, correct. Grand Central Dispatch doesn't guarantee it's a queuing system. So the problem is you can't guarantee the queues will run in the same thread. Correct. It's really, yeah, this is tough, folks. Let me tell you that this is the hardest part of this in general, is like literally understanding threading and just understanding the syntax of how to get threading to work the way you want it to work. Yeah, exactly. It doesn't get Grand Central Dispatch does not guarantee threads. It guarantees a queue of things, and then you have a quality of service that you can set on them. I get Swift does not like you to think about threads at all, but unfortunately, I live in a world where I do need to worry about threads because I have a mobile database, and Couchbase Lite especially, when you want to talk about performance and pure raw performance. you have to start thinking about threads, and you have to guarantee one, you shouldn't really run anything on the main thread. Like I'll give you an example. In Android, we have something called scopes, and the scopes that you run something on an Android, which in Kotlin, for example, I could just say I want to run this on the IO scope, and the IO is input output, and that guarantees it runs not only in the background thread, but it runs on a thread that's optimized for talking to the disk. And that's an Android. In Kotlin, how I do this is, so then what I could do is I could just wrap any like code that calls a mobile database and say, hey, I want scope dispatch IO, and when I run it on the dispatcher of IO, it then goes through and runs that query, like I said, on these optimized threads for talking to the disk. Now that's interesting. That's really interesting. So we've got some comments here in chat that the best experience of Swift is writing code assuming that it's single-threaded behavior, and then putting that code inside of an actor or a dispatch queue, or a thread pool, basically. Let me look at here what I have for examples. I've done this a while back. And if I remember right, let me look at some code I have. So in the past, I've done the thread worker kind of pattern, where you basically make a thread, and then you basically have to do a dispatcher, or like a set of more dispatcher, and then I'm just looking at some code I have on screen here, off screen here, to see. And then that would basically let you basically schedule work to be run on that worker. That worker then runs on a guaranteed thread. Oh, sorry. That's I'll slow down a little bit. I apologize for that. You can remove the parent global actor context also by removing any async baggage that's using test dispatch or detached. It's saying, you're saying. You remove the parent global actor context also. So let me get this straight 1 second here. So what you're saying is that these are great conversations to have. I'm gonna reject this here. Let's go back to this count. Let's just get rid of this for right now and just talk about count from a standpoint of getting it working in the way that we think it's running on a separate thread. Because we have tests, we can guarantee that this doesn't break any of our tests, etc. Ideally, you shouldn't use any of the new task spawning APIs. You wouldn't use any of the new task spawning APIs. Do you have a code example of this that I can take a look at, of what you're recommending? So you're saying to start out with, so if I get this straight, what you're saying is that we shouldn't spawn a task using the new task API to start out with. And you're saying we shouldn't be using async either, which I guess would still lock this. I'm trying to think here, because if I have a UI thread that calls this and then waits, without that, we have the... So you should use async. So async isn't the problem. What you're saying is that the task is where the problem is. The idea of spinning off the task using a task. Let me write some code here. What's quick here? So let's go through and see if we can find out a better way of doing this. Let's see if we can make a person, or a, not, I hate to use the word person, but we have actors and stuff. So sometimes when you say person, it kind of helps with this whole concept. Let's go through and make some super raw code that I'm pretty sure I know works because I've used it in the past. So I'm going to make a utility folder to start out with an inventory here. So let's just go ahead and make a new group. And that new group is going to be called, well, utils. I hate calling it utils. That becomes a garbage dump for everything. But let's just call it utils for the sake of conversation here right now. We'll move it down over here underneath our services. Let's make a new Swift file. And so in here, we're gonna make a new Swift file. That sounds great. Let's call this background worker, right? Let's make a thing that its only job is to do background work. So we're gonna make a background worker, right? Did I do that right? I did that wrong. I think I need to tell it that it needs. Ooh, no, that's also wrong here. Jump the gun here a little bit. Let me go into here, make sure that the test can also see it. There we go. So that way I can use this in my test. So let's see here. Let's close the background worker here. Let's see here. You could write a unit test call in your code that can annotate the unit test as a main actor function to run on the main thread. It's not really a Mac OS Smart House project. This is going to be an inventory application that tracks inventory, and the theory would be is that you could share this between multiple people and stuff. That's really the goal of this app. But really, it's more of a demo of just doing mobile databases than anything else. That's kind of what the goal of this app is to do. Is just basically say, how can I get data and stuff? Hey Matt, how's it going? We're having, Matt, welcome to the party. We're having some ridiculously interesting conversations about threading in Swift, which is more complex than it is in .NET, I would say, only because Apple tries to make it so that you don't have to think about it. In Apple's walled garden, right? They try to make Swift a very elegant language. It does have async await and all those kind of things, but that does not guarantee threading. And in Couchbase Lite, threading is very complex, and it's a conversation that most people that end up using mobile database run into problems, and then they don't understand how to solve. And so usually when I write code for mobile databases, I just write them in a way that I won't run into those problems to begin with. And so one of those things is to just don't run your database code on the main thread. That's one of the worst things you could do. So we're going to write somebody that's we're going to make it so that we have this worker that, and their only job here to do is to basically go through and do background work for us on a separate thread. So to do this, we should be able to do this with Foundation. It's been quite a while since I've done this, so apologize while I go through and struggle through this. But we should make a private var, and this should be of type thread. So we're going to say a thread, but we're going to call it non-there. Threading should be part of Foundation, so that should work. I'm going to try that. The golden tip is for Couchbase is if you need to guarantee synchronous access to it, make a new global actor. That way it never runs in parallel and not on the main actor. So you're saying register a new, with annotations, you would register a new actor. Sometimes see a problem when they think, now I know I have to use two threads. They'll have to use two threads problem. Yeah, so the annotation for actor. Interesting. Let me write this code real quick here, and we'll see if this... let me write this code real quick here, but then I think I want to take a look at this actor concept, because I think this may also be interesting. The problem with... I think actors is going to work for read. And I think you're right. That's the best thing. However, writes have a very specific problem. And this has to do with when you open multiple copies of the database at the same time, which you shouldn't think you could do, but you actually can. So let me explain the story of what's going to happen of why I want to do this worker. I know this worker pattern works because I've used it before in production level things. So what ends up happening is that you're going to have, we have something called live query that's built into Couchbase Lite. What live query allows you to do is anytime the database updates, you get an event that fires for free. It's like, I just listen and I say, hey, if there's new warehouses in my database, just fire this code off, right? And think of it like messaging that you would do like in, what's Apple's framework called for this called? I've just got off vacation. Apple has a framework. They used to have a framework that was really popular for this. Most people don't use it anymore. It's kind of like a database hook. It's more of just like a delegate, really is an event, but it will tell you the when the database is updated. And this is it uses kind of like messaging, very similar to Apple's Combine. Right? So in Combine, we have the ability to send messages. We have a pub sub kind of system. So think of like if the database could tell me that things have updated. Now, the problem is in order for the database to update, it's got to write stuff down from the server, and that's called replication, right? So we're going to take this data. We're going to take this data that we don't know when it happens, but we're going to be writing to the database. All that replication code then needs to run on a thread that has the ability to write, but we don't want it to break the application when the user is using it to do things like, right? Where the user's in the app, maybe they're going through taking in a picture or something, when this data comes down to write to the database, your replication, it can't run on the main thread because the user may be doing other things, and that could literally break their experience of using the camera. And so what would happen then is that so how I've solved this in the past is that you take all that replication code that you have and you run in a background thread with a background worker, and that guarantees that it has nothing to do with UI. It's just sitting there running on its own thread, doing its own thing. However, when that hook hits that we talked about, right, that event happens, it fires, then we publish a message up that says, hey, by the way, some data's changed. And then if you're on a screen that cares about that, that data can dynamically update. That screen can basically just update, see that new data. The user has to pull the refresh if they don't want to. This is really more of a dynamic thing. You will get a copy of the new data. Then it's up to you as a developer to design what do you want to do with that data. It's a very cool pattern. Now, the problem, like I said, though, is that for each thread, and this is complicated database mobile stuff here, right? For each thread, you only can write once. So, for example, if I have this background thread and I have this replicator that's writing to the database, if I have, for example, a user trying to also save data while the replicator is writing, and if they're on the same thread, that person that's writing, say, for example, they're filling out a form on the mobile app and they click the save button, the replicator, if it's already working on writing, they get paused. They'll get locked because of the fact that the writing's not done from this, and only on a thread, only one person can write to the file at the same time. Now, this is where the trick of the butter comes in, and I know this doesn't sound like it would work, but it does. As long as you have multiple copies in memory of the database open, so I have a database connection, and if I have multiple pointers to this database file, this database connection, and they're on the same thread, I can have two different threads writing to the file at the same time. And what ends up happening is that the back end of this system, Couchbase Lite, that's written in C, has the ability to know that. It knows there's multiple database connections node open. It knows that they're on the basically the same thread. And because you have multiple database connections, it knows that, okay, I'm going to grab this. I'm going to make a transaction for the second write. Even though I'm writing this data with replication down to the database, I have this other data I have here that the user wants to also write. It's going to create a transaction for that, and it's going to make all this stuff happen, and the UI never gets locked up. And so this is the most common thing that happens. Yes, I am worried very much about deadlocks. The most common thing that happens when people start to do mobile database platforms and stuff. Hey, guys, we talked like 1.5. Now I'm using Programmatic UI Kit, and I'll create a decent app for pet adoption. Oh, cool. Wow. That's very cool to hear that you're using UI Kit and you're going to do clean architecture with MVVM. Combine is pretty cool. Coordinator pattern's pretty great. That's awesome. That's very, very awesome. UI Kit's not going anywhere, folks, here. I love SwiftUI. I think it's pretty cool. It makes it really easy to write really complicated things. However, UI Kit is all over the place. And I still think it's pretty easy. I'm not going to lie to you. If you did UI Kit for years or App Kit over on Mac side, boy, it just seems like super easy to get things set up without writing any code if you're using a storybook file. Yeah, exactly. Like UI Kit just has every tool. It's super easy. Like I literally, so today, right before I jumped on the stream, I made a real quick Apple TV app using UI Kit just to prove that could I go through, could I get like a stack layout view working, could I throw some stuff in it and get everything working? And it took me less than 5 minutes and I wrote zero code. I just opened up a storybook, I dragged some components in it, I did this, boom, boom, clicked the compile button, and it just worked. And I'm sitting there going, I wrote zero code, and I actually have an application that's actually functioning with very little work whatsoever. UI Kit can do that if you understand how it works. Now, I get constraints suck. Everybody hates constraints. And look, I get it. Once you get used to constraints, it's not as hard as people think it is. It is not that hard. It is basic algebra when it comes down to it. And it's if you understand that in the constraint system, you understand it's a calculation of figuring out the spacing, it gets really easy. So let's go through and try some threading code here. So I'm going to try this, and then let's see here. The more hardcore part of learning iOS UI is what each API is for, but actually feels like not actually hard. It's not. It really is. It really isn't hard. To me, it's really just a lot of times somebody has never explained it to a person in a way that just makes sense. A lot of times, like constraints, if you don't take a class on it, or somebody doesn't show you like the tips and the traits, like how to do it quickly and how to do it easily, then it seems like it's magic or it just doesn't work. And Apple's documentation hasn't been the greatest in constraints. They never give you like these really great real world examples. Instead, they just give you this kind of dry thing when it came to constraints. That's always, at least my personal opinion. Once you sat down and you thought about like how to build something complicated with constraints, I always thought it was pretty basic. You have to have enough to solve an algebraic formula. Say, for example, I have 3 elements. A plus B equals C. Well, if I don't know B, but I know C and A's value, I absolutely can calculate that formula, right? And in constraints, we're trying to calculate how much spacing to put between things. So as long as we can give the constraint system enough information for it to calculate, it will calculate. But it's not magic. And so if you can't give it enough things to calculate the calculation of what to put, spacing wise, then it's not going to work. And so that's why you have to guarantee like all the different UI elements are connected together, because that creates a math formula, right? Not a problem, man. Not a problem at all. I am going to be doing some UI kit stuff actually tomorrow. I have a lunch stream that's going to be going on every day at lunch for me, and it has nothing to do with databases and stuff. It's a personal stream during my lunchtime, and I am going to be working on UI kit in .NET. I'm going to literally build some old school UI kit stuff, but using C# and .NET, because it's something that most people don't know you can do. You literally can write .NET code and build an Apple TV app. You can build a Mac app with it. It's super easy and awesome. And I'm going to show people how to do that tomorrow on my stream. So if you want, come on over and check it out. It's an alternative to using Swift. There is a lot of .NET developers out there, and most of them don't even know this is an option, which is kind of crazy. I actually used to do. For years, I worked at an accounting firm, EY, big, large accounting firm, and we had a lot of Swift, but we also had a lot of .NET code. And I wrote many, many applications, too many to count, probably over 30 applications in C#, but targeting Apple platforms. And this is, some of it was done with Xamarin, and obviously some was done with .NET. But yeah, I've got a lot of experience in writing native stuff for Apple's platforms, but in .NET. So it was just something because we had a lot of libraries laying around that would do business logic, but they needed a Mac version of the application. So it's like, well, wait, I have this code that already compiles that I could reuse. Why wouldn't I just build a Mac UI around this? And then the question came, well, why can't I just use .NET for this? And the answer is you can. So it'd be something we'll take a look at. It's an interesting alternative to doing the Swift stuff that we're doing here. So let's see here. So the next thing we need to do is make it private. Look at some of the sample code I have here. Let me just copy this over. I do want to take a look at this actor option though, because this is the newer way of doing things, and actors are really, really nice. And so then, of course, we talked about this before. This is the big guy, and it's recursive lock. So, like I said, the biggest thing, I do work at Couchbase, so I probably should have disclosed all that ahead of time. I work at Couchbase, so that's the reason why I talk about Couchbase Lite a lot, because I work there. But prior to working at Couchbase, I built applications for years upon years. I've been in mobile since 2010, and I've been doing software development for almost 30 years now, and got a lot of background with Oracle, SQL Server, primary SQL Server, did some Oracle stuff in healthcare. I've done MySQL back before MySQL had key support back in the 90s. I can remember when MySQL 3 came out and we finally got foreign key support. There was no foreign key support until 3, and let me tell you, pain in the butt to use until then. And so, yeah, I started my career in the early 90s, writing C and C++ on Solaris, and then kind of moved throughout the years to different platforms. But I've touched a little bit of just about everything: Java, C#, obviously Object-C. I wrote tons and tons of Object-C, more Object-C than I have Swift, because for years that was the gold standard for iOS and Mac development. So now I need to make a queue, right? Because I want to make sure that this background worker, let's call it background worker instead of worker, because that's really what it is, right? We're going to build a queue. So if we look here, we've got a locker, we've got, we need to be able to dispatch, we've got a thread that we're going to run on, and we've got a queue that we can add work to. And so once we do that, then all we need to do is basically make a queue method that goes through and does this. And you can find this code all over the place on the internet, by the way. This is a custom tweak of it, but this is pretty basic. So when we queue, we're going to go through and make sure we've got our lock. Our lock should be for blocking. And let's see here. The only other thing I'm missing here is if locked. I've got a typo here. So we're going to queue our block. Let's see what's going on here. Is this because... One second here. What's going on here? I am using his extension. I've got the CoPilot extension installed here. One second here. But it sometimes does not work here. And I'm using this one, CoPilot for Xcode. So you can kind of see here, this is the one I'm using. I don't know if there's another one, but this is the one I've been using for quite a while. Okay. That's the one I've been using for quite a while, to tell you the truth. And it's been working pretty well for me, actually, to tell you the truth when it comes to this. So let's see here. What do I got wrong here? So let's start with, let's close our function here. Let's see here. That worked. All right, let's see here. But we say block of work. Let's make sure we have everything working here. So we've got a block. We're saying we want to lock. Cannot call function of non-function type. We've got our queue. We want to append our block of work to the queue, but we want to make sure that this is a lock. Then we're going to do a signal, and then we're going to tell the thread to start our work. What do I have? What am I missing here? Did I not copy a reference over? Oh no, I'm just missing the work. Duh, one second. I need the sleeper that does all the work. There we go. So I need the actual work function that goes through and just kind of goes through and that basically sits there forever and sits around and waits to see whether or not there's work to do. And if there's work to do, then it goes around and does it, right? So while true, I know that I hate that, but let's see here. We should be able to remove from the queue, and then we basically run block again. So the music's a little bit too loud here. Let me turn that music down. There we go. Correct. I totally agree, right? I'm just trying to get some sample code in to the point where it works. And then we'll go through and tweak as we need to. Let's see. Why are we mad here? Do I still... No, the function should be closed here. Still got... Where lock isn't working right. Oh. I see what I did wrong. I forgot the locker, the generic. Let me get the generic in here. Sorry, I have to fiddle through a bunch of old code that I've got laying around here. This is what I need, and then this should be locked because this should use the generic of passing in whatever the work is, and then this should be locked. And now let's take a look at this. All right, so let's see here. So we do have to fix some things, like said. We need to wait while true, sleep until we get a signal that items are available. We're gonna wait. If the block equals locked, remove first from queue. First we gotta check let block equals locked, and then we have to go through and make sure that the let's see here. Wait, you need to check the queue is empty. Correct. So I think what we need to do here is we'd have to say first, come on, VI key bindings, work for me. Why are not key bindings working? There we go. We'd say if queue is empty, not and that should that should basically only remove the item from the queue. Oh, what's it mad about now? This should be the close of the if. This should be the close of the block. What are you showing? What are you mad about now? Block is referred to a type. Explicit type. Wait, no, wait, what? Lock this down here. Let me close this so I can get more of this open at once. All right, let's see what's going on here. Why is it mad here? So we in queue, we grab something, we go through, add it to the queue. We signal, then we check if the thread is null. If there's no thread, yeah, the Vim support side of Xcode leaves something to be desired, to say the least. So we're going to check if the thread is null. If the thread is null, we need to make a new thread, right? And we're going to tell it to do a block of work. We have the work defined already. So by theory, that's our function here, right? So we're going to say, hey, start a thread. We're going to do this work here. And then we're going to tell the thread to start. So that's pretty basic here, right? If we don't have a thread, when we queue something in, create the thread, and would start the work. The work's going to say it's going to run forever. So first we need to sleep until we get items. So then we're going to extract the thread, right? And you can see here it queues at least one element. So we go through letter block, constant block referred to as type, which may be unexpected. Saying that it wants, okay. We then check if the queue is empty. If the queue is not empty, right, we have the not in front of it, then we want to remove the first item, and then we basically call it the block. And then our lock should go through and do the block. We can see here that we do a lock, and then we defer until we unlock, and then we run block. That should work. No, return block is here. Let me just check here. You're saying that it's mad because there's no return, but no. That's not right either. Because technically speaking, that wouldn't be there. The return for the lock should be here. Oh, I see what you're getting at. So it's because I put the if statement in that this is no longer a single line. So now, so the problem is that when I go here, it's fine because I don't have the if statement wrapped around it. We have let block equals locked. But really, if But really, I should be able to do both of them on the same let statement. I'm trying to think here. So, the most of, let's see here. One, let me take this out because this is wrong. This is what's breaking that. That should get that to work again. No. If let block, oh, yeah. All right, let's get this to the point where it compiles again, and then we'll fix the problem where if the collection's empty. All right, so that should get it to compile again. So now, but the problem is that we can't really do this if the queue is empty, right? So we need to go through and say, try to think here. Well, that's the question, right? Whether or not we wanted to say, you know, if let queue. No, that's not really a good idea there either. Queue is not nullable. So checking it wouldn't work either. There. Let's just start with this. If Q is empty, not so that's ugly as hell because really this should be on the same line. First time chat. Hey, bro, what do you think about Golang? What do I think of Golang? Golang is an interesting language. It's kind of cool for really complicated things that you'd normally do in C. Is it better than Rust? I kind of like Rust syntax a little bit more, to tell you the truth. But Go's ability for how it handles starting, for example, its streaming capabilities are more like, well, one, I like Kotlin's concurrency system that Kotlin has. Its coroutines is pretty, its streaming platform is pretty great. It's how it handles that is pretty awesome, and probably better than most other platforms. However, it's terrible for writing things like APIs because you have to do so much work by hand. It is not fun, to say the least. It's just not fun. It is terrible because yeah, exactly. It's amazing for things like Lambdas. There's a lot of things Go does that is just amazing. But if you're trying to build like a REST API, or you're trying to build like maybe like a what's the new system out there that Google created that's really popular? Boy, I'm just coming off vacation. I can't remember anything anymore. If you're looking for any kind of that kind of stuff, if you're trying to build something to communicate back and forth with, Go is not necessarily the greatest thing in the world because there's a lot of boilerplate code you have to write, and that doesn't make it fun. So what we're saying here is that we would have to do this inside of the queue itself. But this goes back to the threading thing again, right? Because if I do it here, it's no longer a single line. But we say is that the syntax for Swift? Yeah. I don't remember the Swift syntax for this. Nope, that's not what I want either. Try to keep this in a single line. No, that won't work. Q pop first. Nope. There's just a pop last. Is there's just remove first. This is probably hacky. If let block equals lock, that's not going to work either. I was going to try to combine this together with that to create a statement for it. No problem on the Go stuff. You think I had it backwards, where I'd say, you're saying if Q is empty, question mark, nil, otherwise remove first, which is technically speaking what I had but backwards. Because if it's empty, yeah, because I was doing the not in front of it earlier. Why is it mad about this now? Now that should work. And then now I have to do is deal with, did I accidentally close this function? Where is it? Yep. I did the famous, I have too many squiggly brackets here. All right. Now we should be able to go to the editor and say, where is it? Control A, editor. Now remember the structure, reindent. Now remember the keyboard shortcut for that. That should reindent it. All right, so that's a background worker. That should, by theory, fix the issue with background threading, right? I know that this code works. I've used it before. Not necessarily the most friendly Swift code in the world, right? And this is equivalent to if you did NS threads back in the old days. It's almost the same stuff. In fact, I want to say I think this is converted, if I remember right, from Object-C code. 1 second, I got a cough. Still not 100%. So this should, by theory, so what we've done is we've created some things job that it's going to be this worker, right? All we have to do is give it work to do. We don't care what that work is, and then by theory, it should just be able to go through and do that work. And then you just enqueue whatever you want to do on top of it, right? And so that's another way of getting around this. And so we have this background worker. So the theory would be is like in count. One thing that we could do is right now you can see here that we're basically got this whole entire thing where we're creating a task using the new framework. Now this is something where we were talking about in chat that a main actor may be a better solution for this. It is a dispatch queue without the eventing loop and a controlled thread that you can guarantee is there. You know, that is literally what that code is, right? Because we want to guarantee we know what thread it is. We're always guaranteed it's the same thread, right? That's the theory of why we would do this. You know, in that world where you need to guarantee that the thread that you're running on is the same thread. And the example I gave you is this really weird, not necessarily real world. If you understand why Couchbase Lite does what it does, because it's C, it's not running Swift, it kind of makes sense. Exactly. If you look at libdispatch, it's not that much different. And the theory would be is because of that fact that in this world, most of the time customers that we have complain is that they're pulling data down with replicator. So the they don't know, by the way, when data replicates, right? They don't know that the server has new information that it pushed down to the mobile client. The mobile client's getting this data from the server and writing it to the database while a user is taking a picture and then try to write something to the database at the same time. And this, we don't want that write that the user is doing to get blocked by the fact that the replicator is writing to the database. And so the theory would be is that how most people handle this when you have this kind of complications in your application is you make two connections to the database and you open that same database file twice. One connection you have to the replicator and one connection you have is just for the rest of your app to use to write. That's your main thread version of that, right? And as long as those two connections to the database are doing writes on the same thread, which we're going to control that background worker, then they both can concurrently write to the file at the same time. The reason for that is because obviously we make something called a transaction. We hold it in memory. We can say, hey, look, we know that we're queuing over here. We can queue this over here. We can make all this magic happen it does have a lock page. You are very smart. Good Lord. Yes, it does have a lock page. It is exactly how this magic works. Behind the scenes, we have the encoding engine in Couchbase Lite is something called Fleece. And that is written in C, super lightning fast, allows us to encode JSON data in real time down. But then when we write down to actual disk, our writing the storage engine, we call it, that is actually SQLite. And so we take advantage of all the things that SQLite brings to the table. SQLite is ridiculously efficient when it comes to just about anything. And that's why if you look at Swift data, you look at core data, they both use SQLite in the back end. we don't use so we no longer use WAL. That is a very complicated thing to get into. SQLite is, I would say, probably the most robust platform on the planet when it comes down to it. You can just use it for just about anything if you understand it. Indexing can be tricky on it. I think that's really something that most people don't understand. If you do SQLite right, man, even a table scan actually is not that painful if you know what you're doing. But like I said, index is something that in SQLite you definitely have to understand. It's not a full server-based database, so there's some restrictions in how and what you can index. So you have to understand that ahead of time. I think most of the time when I've talked to people and they've get burnt, especially when it comes to indexes, because they understand the restrictions that SQLite has in indexing, and that's a rather crying shame, to tell you the truth. But the theory would be is we've got this really cool worker now, right? So we should be able to, if we wanted to just test this out, to make sure this is working, right? And we're not going to keep this code because I think I want to take a look for reads. I want to look at the main actor stuff. This is, once again, the example I'm writing, this is real world stuff. This isn't like theoretical anymore. This is something that I would want to give to like if I was writing this for a company and I got paid, I got a paycheck for this, right? It needs to be that. So I want to take a look at global actor, but I want to check out my background threading work first. The background worker is only going to be used for writes. That's the only time we're going to use it. For everything else, we want to use the built-in Swift stuff. The concurrency that actors, the system that comes in Combine uses this also, by the way. It's really good. It's written for Swift, and it makes it so that when the developers run their UI, they don't have to think about all this crazy threading stuff that most developers' brains are going to melt when they see it, because they're just trying to get a UI on the screen. They, most mobile developers I talk to don't care about all this stuff. They're just like, hey man, how do I get my list to show up on the screen? I don't like to think about all this crazy complicated things about like scheduling queues and how do we guarantee that this thing doesn't block this thing, and now the whole system's locked by this and this and this, and it's it can be a mess, right? They don't want to go into that technical stuff, so we want to make sure that we only go to technical when we need to. And the honest to God answer is the only time you have to worry about this is writes. If you're just doing reads all day, it can be done with just about any of the stuff that's built in, and it's gonna be great. That is 100%. I used to use thread as main thread all the freaking time back in UIKit. UIKit's a whole nother conversation piece about how to get all this kind of stuff done in. All right, let's try this. So we've got a task here. You can see that I'm wrapping this entire code around this task, right? But really, all we have to do is wrap this code by theory around our worker, right? So we should be able to just say instead, let worker equal background worker. And then we're going to say we want our worker to enqueue some code. Now I'm going to take this task stuff out. So give me a second here. We don't need this task stuff anymore. Let's take task out for right now. And by theory, let's see here. Cannot use optional chaining. What did I break here? Is this now no longer null because of the fact that we no longer have to do the weak reference to self? I think that's what's going on here, because database manager would always be set. Is database manager a singleton? Is it a singleton? It is not a singleton, but I have it defined as not nullable. So because of that, that's what's going on here. Okay, so why did that change, right? Yeah, self is not, so it's not weak anymore. So the theory would be, so why do you need that? This has to do with making sure you have a reference to yourself, but you're not adding to the stack counter. So you, technically speaking, you don't even need self anymore here, to tell you the truth. It should be just this by theory. Now the problem though is we're doing work on the background thread. So now you got the real problem that you literally could reference yourself out. Let's see here. So now it's mad because shoot. var has got to be assigned outside of the thread that actually works on it, because otherwise, and I gotta think about this for a second. We'd set var here, then we'd have to return var out once the work isn't done. But enqueue is generic. Let me see here. Let me check. No, it's not. It just returns a void. That's where the problem coming in is, right? Let's see here. The queue is also, so when we queued out, the problem is that we only could do work. We can't really return anything from it, right? Because of the fact that we're, but if I do, I'm trying to think here. If I do void, what is that? Uh-oh, wait. Got something coming from chat here, hot. No, you can fix this using async-await. With check continuation is your friend. Let me take a look at this real quick here. All right, let's see here. Oh, our good friend Paul. It's got a little thing on this. Let's take a look here what he's talking about. Looking for the syntax. Await with continuation in. So in this example here, he's saying that I could await but in his example here, well, that's the problem, right? So, folks, let's talk about, for some people that may not understand some technical conversations, what we're having here. Let's talk about this for a second, the risk and reward of this to understand here. So when we do work, right, if we talk about this for a second, if we do count here and count is not set, let's go back to the worker here, right? The problem here is that, technically speaking, this enqueue doesn't know how to return count, but this function says it needs a count back. Well, all this is doing is returning from the enqueue, and the queue isn't set into anything, right? So there's no way that count can be returned then. What we're returning out of here is the work that's being done. So the theory would be is, okay, well, wait a minute, Aaron, I know how to solve this. I'm just going to take count and define it outside the worker, right? Well, now the problem is that if we did this and we said return count, you're not going to like the answer you get back from this, right? Because the problem is while this worker is running, we could very well, if I take count out here, we very well could return this with 0 because the worker may not be done. This is on a separate thread. You can see here, and the IDE is even saying here, hey, dude, you got count, but you've never read from it. You're not doing anything with it. What's going on here? And you're like, well, yeah, I did. It's down here. It's like, no. That's your background worker that's using this, not the same thing, right? So the problem is going to come in is that if we do it like this without thinking about this for a hot minute, we're going to have bad code here. We're going to have code that the count, technically speaking, isn't... do I have an extra... Let's see here. Let me reformat this. I never remember this darn shortcut for this. Let's see what it's mad about now. So initializer binding must have optional type. Wait, what? Yeah, so now we have the problem of like where we need weak self again, right? Because if we don't use weak self, the problem is that we need something like this. But we don't want a reference kept to it. So, crap, 1 second here. I got the syntax backwards. I need to make a reference to weak self so that when I come in, you also could do to capture those two values in the same line. Yeah. Well, no, wait. I do have those right here already. Oh, you're saying capture the values coming in instead of doing the reference to self, because if I do the capture coming in, then I don't have to devalue them, or I don't have to reevaluate them inside the if statement. Yep. I am with you on that. That is the better syntax for this. So it's like, so I was trying to make a, so once, let me go through and explain the differences of what we're doing here. All right. So if I do this, I'm given a pointer to myself, but it's not going to go against a reference counter, right? Boy, do I want to get into auto release and stuff. Okay, for the sake of this, let's not get into auto release and stuff. We'll just talk about a weak self means that we're not taking a hit against a reference counter. Okay, this is far more complicated than that, but let's just try to make this a simple conversation for anybody that doesn't understand pointers. All this magic. This is going to get like a very confusing conversation real quick, right? References happen regardless if you're using a language that has this little star in it that says pointer versus you are using a language like C# that just says the new keyword. Those are still references. Okay, folks? I don't care if you're using a garbage collected language, right? Like Java or C#. If you don't see the star, you still have references. You still have pointers. In C#, for example, the pattern is the iDisposable. And iDisposable gets rid of your stuff when you're done with it. It recommends when the garbage collector should get rid of something. Most languages like Swift use reference counters, and there's something called the auto release pool. This is in C#. In Object-C. We would make before we had auto release pools, we would have to maintain reference counters. But what this weak self is saying is that I want to make a reference to myself that I can access anything that's currently in this object, and this is this warehouse database repository, without taking a hit on having a pointer to it to add to my count of when I can get rid of it in memory. Okay, so that's one way to do it. But what we're getting from chat here, and man, I'm telling you, you have to follow. Do you stream, by the way, Jonas? Because if you do, man, you got to follow, because amazing information here from one of our people in chat here that is just ridiculously smart at the understanding of concurrency in Swift. Super smart, absolutely right, that the better solution for this is instead of, you're very smart, and I think a lot of people would love to see you stream. It's not as hard as people say it is. I'll be honest with you. It's just not as hard as people say it is. I think I would watch you stream. There's no doubt about it. I like to watch people. I mean, here's the whole thing. If you're new to development and stuff, my first recommendation is find a job where there's people smarter than you to work at, because you're going to learn so much from them, right? All the knowledge I have is because I worked with other people that were smarter than me. And even the job I work at today, I have tons of people that are smarter than me working there. My feelings aren't hurt when I say that. I work at a really great company that has a lot of really just super smart people at it, and that makes me learn new things every day. And so anytime you can share that knowledge, that's why I'm streaming today, is to share knowledge with people. That's the only reason I'm here, because somebody shared knowledge with me, and I feel bad that I don't necessarily always have the ability to share with others at my job every day, because it's just the role I'm in. So this is my ability, is trying to share some of that knowledge of like how to make the world better for each other. So what we're coming to the saying here is that if we were to just basically capture the values that we need from up here from our object, then we don't need this two statements here, okay? Because the theory would be is that technically speaking, we know about it already. So we can kill this let statement here. We can say that kill this let statement here. We don't have to unwrap those, because of the fact that we captured them up here in our in statement, right? And this would be, it's database manager, because I changed the name of it when I dewrapped it. And so this would be the same thing here. We'd have to just say it like that. And let's see here. And then, of course, we have this problem here because I changed the name of it when I aliased it. That's probably not the Swift term for it, but yeah, I mean, share any love anytime you can. It's so important as developers. I mean, I think that there's going to be a time where I'm gone, and I hope that, I provided some value on this planet, and you work 8 hours a day. If you think about it, folks, let's think about this for just a quick second. There's only 24 hours in a day. If we take 8 hours away for sleep, you should all get eight hours sleep. Let's just be honest, right? Okay. That means you work for 8 hours. Okay. And then that means you only have 8 hours to spend with your family and friends. You're saying a quarter of your life as an adult will be spent working. That's a quarter of your life to have. Now, sleep, you get value of regenerating yourself, right? That's important. Your family and friends time, that's the value in that is that you're making a difference for all your family and friend, and you're enjoying that and stuff, right? But if you go back to that work thing, then how are you making a difference with that quarter of your life? That's a big chunk of your life, right? And a bunch of people made my life better at work. How can I give back so that other people can get that? And the whole thing with development is if we all do this, if we all just help each other out and we constantly keep giving back, then this is the thing that just keeps on giving. And as long as everybody follows the same system, the world's better for everybody as developers. And so that's my theory. There used to be a time when I remember back in the 90s, the early 90s, where sometimes developers would write really complicated code just to prove they're smart, or they would write code so that other people would understand it so they thought they had job security. That doesn't exist anymore. Don't do that. It's terrible, right? It's not great. It's not a great idea, right? So write readable code. Write code that works. Write readable code that can be maintenance, because the true answer to this is that most of the time it's you that's going to have to go through and modify your code a year from now. And if you don't understand it because you wrote it so crappy, so obscure to keep other people from maintaining it, then you probably can't maintain it either. So don't write bad code to start out with, right? But that's the theory of why I stream. That's the theory why we all should help one another out. And yeah, it is. It really is when it comes down to it. For my work, this is my legacy. This is out on GitHub. This will go out there. Any developer wants to read it, it can. This isn't just for Couchbase Lite. Other database systems like SQLite, we talked about it earlier. These are very similar problems to solve, right? Almost all database systems on mobile are going to have this right problem where you have to start thinking about this a little bit hard. It's so important that today, I know that like a lot of my stream, a lot of you all are new. It's okay. If you can't contribute today, you're here to learn. But once you are 10, 15 years down the road and you're now where I am, or even higher than where I am, I'm hoping you all are, just think about that for a little bit of how do you give back so that you can return what you gained from watching streams from anybody that's streaming or anybody's blog article you're reading and stuff, because that's how you got here, right? It's just important to me that you figure that out, or keep that in the back of your mind for the future. So our test should still work here, right? And so the theory would be is that now that we've got this, the problem though is this is going to fail. Learning is not a waste of time. There's my first boss I ever had. His name was Charlie Gershfield. Super awesome guy. Worked in the defense industry for years. Was a genius when it came to C, and especially really complicated physics and math in C, because he worked for the defense industry and they had all this complicated missile guiding software he wrote. He used to tell me the only thing somebody can't take away from you is knowledge. He said, no matter what, the government could take away your house, they can take away your money, they could take a lot of things away from you, but nobody could take away your knowledge. No physical person could do that. So it's like, keep learning. And I learn on a daily basis. Try to learn something new every day if I can, because then I feel like my day is worth it. So this is going to break. This is not going to work. In fact, let's go run our test, because I'm 95% sure that this is actually really bad. So let's go ahead and just run the count method here. And we should get, hopefully, this test failing, which it did, right? Now I said that. And the reason why is because we have count here. We're modifying it here, but this doesn't know about it here. This is still set to 0. But the count should not be 0. If we look at our tests, in fact, if we go back and look at our warehouse test that we have, let's go ahead and look at our warehouse test. We'll look at the count test here. We're saying that it should be equal 18, but it's equal to 0. Well, that's because of the fact that, once again, like I said, we define count here, we modify count inside of this thread, but we're not returning it outside of this thread. Think of this like almost like a whole nother reference that's going on here, that it doesn't know the literal value return. This is the complications of threading. And this is why, Jonas, when we were talking to chat earlier, we said that, Swift hides all this stuff from developers because this gets hard and complicated. Now, you're probably saying, well, how do I solve this problem, Aaron, right? Well, if you think about it here, we enqueued here. So one person would say, well, wait a minute, can't you just pass count in here? But the problem is you're going to get this right here. Count is immutable because we're passing in a immutable reference to it, right? That's not going to solve the problem. So where these two things we don't care about, because if we look at it, they're let. This is a let, but really Database Manager, we're not changing. We're just basically calling something from it. We're getting static information from it, okay? So in that theory, since we're not changing it, we could pass it in this way, and it's not really no cry, no farm, right? But the problem is that count, it's not getting modified right? So we were talking about this earlier, that one thing that we could try to do to fix this is we were talking about this whole async await. And so what we could try to do is, and if I remember this right, I'm looking here to see, there's with checked is, so let's go take a look at this. I want to look up this real quick. And folks here, look, man, I've been doing this for 28 years. Like I said, 28, 29 years. I look up documentation all the time. So if you're saying, well, geez, should you know all this stuff? It's like, I don't remember syntax stuff all the time, man. I have to know 6 different languages at my job every day. Let's just check this and see the Apple Doc. One sec here. All right, so what we have is with checked continuation, we have a generic, and it returns a value back, okay? So we can see they also have a couple other for throwing, and also unsafe. Don't use unsafe. Anytime you see the word unsafe, it's unsafe. I mean, I don't know what to say. That is probably a, and we see here that's been depreciated, so don't use this one. Use one. It looks like this is probably a non-generic, and this is the generic version, right? But if we look at this and we look here, we're saying check with continuous. We're going to get something back, and we're going to return that, right? So we could do some work here. And so the theory would be is we might be able to wrap this. We probably should be able to just wrap this code around it if I remember this right, because you can see here this is a closure, right? So do they have an example of code here? No, that'd be too useful, right? This essentially it's the async await promise, yes, from other languages like JavaScript. So if we look here, this is this is our body is basically what we're going to run our code in, right? So that's our thing that we need to go through and we want to do. Sorry. I'm a rather sarcastic guy from time to time here. My boss says that it's sometimes missed and sometimes not. But this is exactly what we're looking to do here, right? We want to do this. Now, if we look here, Paul probably... Well, this is also the Google AI. I guess this now came out in Google here. The with check function evokes passes. You write the async after its return type. So, this is where it got it from. So this is saying here... Well, this is just a standard async await. I don't think this is gonna. I don't know where. Let's see here. Running loop. Nope. Boom. Add. This is what you normally would do, by the way, folks. This is perfectly acceptable code. Just remember that you're not guaranteed to have threading with that. I don't care about any of this. That's interesting. I mean, it's a good article if you're new to async, but so what is Paul saying here? Paul, I consider one of the people out there. This guy, this is his whole life, is just helping people out. I have not met Paul yet in person. He is literally a very compassionate person that just has a heart of gold. There's nothing I know. There's no way anybody could ever say anything bad about him. I'm sure he's got flaws, but the guy just really cares about people a lot. Love his dogs too. I mean, his dogs are pretty cool. Let's be honest. I'm a dog guy. Yeah, and I mean, he's built so much of this just from nothing. From that website being where it was when he started to where it is now. I mean, he is the defunct. Most of the time, I'll go to his docs before I go to Apple's docs. I'll be honest, because Apple doesn't give you good code examples. He gives really good code examples. He has done several streams for charity, and they are really great. Anytime Paul does a charity stream, jump on and help out however you can. I have donated in the past, and I really like it a lot. So Paul's saying here, so I'm just looking for a cheat sheet so I can look and see the syntax for this. So he is saying, if I go back here, I already have my async here wrapper, so I do want to return this. And so what he is saying that we would await, and then this is where we're going to do our with checked continuation, and then we're going to say continuation, but I'm going to type that wrong, and I'm going to steal this from his code here. It's not stealing if you give credit. And then we're going to say here in, and now we have all this work that we're going to do here. Oop, that did not work the way I wanted it to work. Oh, it's not here. This needs to be this here. We need to add another one here. Into now, what we need to do is, count needs to be outside of this. Continuation, and then what we need to do here is count can be in here because we're going to return count inside of it. So we define count in the worker itself here. 1 second here. Sorry, as I get my bearings back on here. So what we would do is we'd say count outside of here, then we would say here, instead of count, we set count to that, but we say continuation, resume, and we say returning, and we return the count. Sorry, it took my second for my head. That comes back from that. Let's see here. And we don't need this return anymore. And is the compiler happy? Wait for a second, wait for it. Oh yeah, well in here we would say, actually, let's just return 0. We should never get there, right? But we could have an error. Something could go wrong in the world. Wait, what? Function is unused. That shouldn't fix it. Yeah, I was gonna say that shouldn't fix it. We'd have to do the continuation. We'd have to say resume, returning 0. Because that will catch the error. You're right. The error states the problem here, right? Actually, we should just be able to say count because count is getting referenced as 0 to start out with. Now, boy, let's talk about reference counters for a second here. So, Jonas brought up a really good thing. We're making a reference counter here. One of the concepts is, do we need that? Every counter that you bring in is going to take up memory. And that's going to go on a stack, right? And it's an integer, I get it. So it's a struct, not a big deal here, right? But technically speaking, is this the most efficient way to do this? And the answer is, well, we're only really using it here and we're returning it here. Well, technically speaking, unless we're going to use this variable somewhere other than here, the only thing this buys us is a breakpoint. What do I mean when I say a breakpoint? Okay, if I put a breakpoint in here, I can check its value. Now, you could check the value using LLDB also. So technically speaking, just putting a reference into this just to be able to check that value, some people would say that this is an inefficient use of a variable, because what we're really looking for is we could say here, we could just put that in. And since var is a count just set to 0, we could just say here returning 0. That is the equivalent of the same code, okay? But the difference is we have saved ourselves a reference. Correct, right? Well, is it? Let me think about this for a second. So we made a count inside of our scope here, right? Set to 0. We then take the value from this, put it in here, and then it would basically come off the stack at the end of the scope. With this here, one second. Let's see here. Close. Let me see here. Got some code here to bring up here. This is great. This would be what we're getting back into the assembler. Let me see here. So is this Swift? Oh, this is C++. Can you do Swift inside of this? Or is this only C++? Oh, it does work with Swift as well. Let's check here. I'm looking here. See, exactly same. You can check the instruction there. Note that the Swift on debug compilation does not inline perform optimize your code, and it'll be actively harmful to promote debugability. Works in Swift as well. On C++, drop down to the right, left of the tab. Over here. Well, I see this is the output. Wow. Holy crapolas. Okay, that's... So this would be GC... Okay, so this is the output. This is the input. So over here, we'd have to tell it in the input over here. Right here, C++, so I'd say Swift. So we would say here... One second. I get what we're cooking here. Let's just write some scope code real quick here instead of square n. Count, and we're not going to take any variable back, but we're going to do this. And what we want to do is say do and say catch print foo. Actually, we don't even need to do. Well, we do because we're trying to check the scope. This is actually pretty awesome. So by theory, we could say var let's just do this. So you can see here. Okay, so we've got a push. A move would move values, right, to two different registers. And so here, why are we doing a sub of 16 bytes? XOR would be compare. Then we move the value back out, and then we bring it back. Huh. 1 second here. This is one of the coolest things I think I've seen. Yeah, though this is pretty amazing, actually. Wow, I am impressed. Versus, so here you can see here, this is the optimized version. I'm just, once again, I'm not trying to put all my code in there because I have to put all my classes and all my subclasses stuff. That's just not worth the test here. The true concept here is that in scope, if we were to basically, we're taking a look at the efficiency of this code right here, right? These 3 lines of code here, versus just saying, I already have test value here. Can I just return test, right? And then the theory would be, so one of the things I'm looking to see, that's very interesting. That's very, very interesting. Okay. Yep. That's very, very interesting. I'm a big 6502 assembler nerd, so I love assembler. It's pretty great. Obviously, 6502 is way easier. We only have the accumulator and the XY registers, so it's a lot easier than reading this code, which is far more complicated. But if you have a chance, go play with some 6502 assembler because it's pretty great. So what we're getting at here is, we talked about this. We had this var count equal to 0. And the answer was, what I was talking about here was, if I said count equals here, if I go back to this right here, the theory was, and if I just do it outside of here, right? If I do my reference outside of here, I don't have any magic ints. And I could technically speak and put a breakpoint here and see the count value without having to do a LMDB. Yes, I always want to. I want to control how the return works, right? There's something to be said about that. You know, that I want to guarantee at least something comes back out of this, and that I can guarantee I know what the value is to start out with, right? That's one of the things, if we think about it from a program like nils or nulls, right? One of the problems is that that's sometimes unexpected behavior. And this is very similar to the concept of, I want to control the behavior. I want to guarantee that the behavior works a certain way. And when we code that way, where we guarantee we know the results of something regardless, it just makes our code more stable, right? I mean, there's something to be said about that. And the problem is this code isn't complicated, but if you look at it, it's also getting pretty long. But I'm not worried about me right now. I'm worried about the next person that picks up this code a year from now and then reads this as a modify it. And it's the modification of modification of modification. The original intent sometimes can get lost of what the developers try to do, and that's where we run into problems. That's literally how bugs end up happening, is because of that fact. The person that's modifying this code 2 years from now doesn't understand the intent that I originally had. Well, if I make that count variable, it's pretty obvious what my intent is here, right? I'm going to say by default, I don't think that the database has anything in it, and then prove me wrong. Here's some work that will go through and prove me wrong that maybe there is some stuff. At worst case scenario, there's still nothing in it. I'm still returning nothing, the number 0, right? And so that means that all my code now at least gets a value back. And if this is SwiftUI code, for example, and I have to return that and put into a label, for example, so I can display it out on the screen, having a number there is better than not having anything. And now you have this code where you're trying to detect, oh, if I didn't get anything back, I need to draw this versus this, right? That there's something to be said about that. let's see here. Oh, sorry. I got distracted with trying to explain this. Look at Jonas' recommendation here. Would only do one resume now. Oh, yeah. So the theory would be is that we need to just return what happens here, right? Now the problem is we should take this outside of here, and we should do this outside of the do loop and do it here, because that way it doesn't matter if we're doing it in the do loop or the catch. Count we have a reference to. We always know it's going to be. And since count is defined outside of this loop here, right? If we just close this out, count's there. So no matter what, count is going to return either 0 or this work here is going to do some work for count, and it's going to give us a value other than 0. But we really don't care, because as long as we have this reference to it, we're doing it here. This is more efficient than doing the return here and then also the return here. That's very bad. We did it there because of the fact that I didn't have a pointer, because I took the pointer out, right? And we're looking at the differences between should you have the var count in there versus not have the var count in there. Most of the time, my favorite thing to do is put a breakpoint here when I'm trying to troubleshoot to see what this value is. And I know somebody's going to yell at me in chat. You could just do a LLDB, just go in and probe the variable value. Yes, I know I could do that, but that takes extra work, right? And this, I can just hover over it and see the value. There's something to be said about that. So from a debuggability standpoint, this is, I think, a little bit easier. This is how I normally would write code. Unless I'm in a very finicky environment where every reference pointer counts for something, and then at that point in time all gambles are off and I may be going to some pretty efficient code. I don't write that much of that kind of code anymore. The last time I've had to write that was on I worked on a secret project I probably shouldn't tell anybody about, but I can tell you this: it involved drones, and we wrote some software that would load onto a drone, and that software was like a POC, and you'd have to be able to. We were calculating certain things in inventory warehouses, okay, and on that, oh, absolutely. I will definitely follow you on Twitter. That's super cool. I appreciate that. So we wrote this POC software that ran on a drone, and the problem was that the drone's battery only has 20 minutes. Every drop of CPU that you're using, every drop of memory you're using counts against the battery. And so in that world, you have to write some of the most efficient code you can write. And debuggability is important to me, but in that world where like literally 20 seconds is between the drone finding its ability to find the spot that it needs to dock to recharge and not, then every ounce of battery counts. And in that world, you are looking for efficiencies, and you're looking to trim off any fat that you can. And let me tell you, that, and when you have to write in those kind of constraints, that's really kind of a really hard environment, and I wouldn't write this kind of code in that environment. I'd write much different code. I wouldn't use Swift either, to tell you the truth. I love Swift, but it doesn't work on most of these kind of boards. You'd use C. That's what I'm used to using. Or if you don't care about performance, the exact opposite, you can use Python, which runs really well on those. But Python is terrible for performance, at least right now. You're not going to Python for memory efficiency. You're going to Python because it's easy to write. Let's run our test now and see what happens here. Our theory is that we should have fixed our threading thing, and it should just work. Let's go ahead and start our test and see what happens here. We also can put a breakpoint in here. You can see here and see what happens, and our test is now green. So what did we learn today, folks? All this came down to one simple thing we are talking about. Let's look at a different count method. I know I have another one in here. So we can compare and contrast of what we did today and whether or not it was worth it. The answer is, well, learning makes everything worth it, if you ask me. If you learn something new, that's good. If you didn't learn something new, that's bad. Okay, so here, I've got some new Swift syntax, right? That's trying to make a task that's counting. Okay, but the thing to remember is that this code, which we did over here, totally different. It's not guaranteed to run on a background thread or even another thread. There's really no guarantee of any of this, right? So we went through the exercise of well, how could we guarantee that this particular code runs on a separate thread that's not on the main UI thread, and it's guaranteed to run on a thread that we control. And so how we did this is we used a background worker that we created. So we went through here, we made a background worker, we used a thread, and I do believe that in Swift this thread is just NS thread. I'm assuming this is our wrapper around NS thread. I'm probably 99% sure of that. Well, not 99, but I'd say 90% sure this is probably a wrapper around NS thread. Probably with some Swift love on top of it for syntax. We need to build a queue of work that the worker could do. And then we basically have this in queue that adds the work to the queue, and then we'll work on it if there is work to do. Okay. And that's what's done inside of this work function. There's some things in here that I'm not hugely a fan of, to tell you the truth. This is some old code I have in. This came from Object-C land, I want to say, a long time ago, and then I converted it. Yeah, that's what I thought, that most of the NS stuff is going away just because of, you know, the old next step prefixes are no longer preferred. I know even with like UI kit, when we have app, if you go do back development in the app kit, you will use NS all day. You'll use NS label. You'll use NS text field. But when they went to UI kit, they made it UI. You know, UI label, UI toolkit, all those kind of things, right? Because they put a different preference in front of it. There's nothing wrong with the word NS or next step, and that's where all the stuff came from. It was Object-C with next step, which was the operating system that all Apple devices are based off of. Most people say, well, that's Linux. That's wrong. It's actually based on next step, and next step is actually based off of BSD, not Linux. BSD is the exact opposite of Linux. BSD is a clone of System 5, which was a Unix platform. Yep. Next was awesome. And so I want to say Mac OS is called Darwin. So if you ever want to go understand the truism of like how iPhone works, Darwin OS. This is the operating system that Mac OS is based off of. Mac OS X, iOS, all those things are based off Darwin. Darwin is based off of BSD. Well, Next Step, and Next Step is based off BSD. And you can go see here that, you know, Mach was the original kernel, was based on BSD 4.4. I have looked at the book. I actually was a BSD kid. When I went to college in 94, I ran BSD because we had Solaris boxes in the lab, and that's the only way I could compile my code and get to work in the lab. Yes, and this is super awesome. They hired, what was his name? The famous guy from BSD. They hired over like in the late 90s, the maintenance, the ports kit. What was his name? It wasn't this author, Jonathan Levin, but there was a famous BSD guy that they hired from the open source community, and it was phenomenal to see the fact that they hired some really cool people in the community. Most people don't realize that. So, fun fact you've learned on the stream today, if you didn't know this, Mac OS, iOS, Watch, iPad, it doesn't matter. They're not based on Linux. They're based on Darwin. Darwin is an open source operating system that Apple created based off of Next Step. Next Step is based off of BSD 4.4. And there's other BSDs out there. There's OpenBSD, which is really great. Runs on really old hardware if you're building a firewall or something like that in your home lab. OpenBSD is your friend. FreeBSD is what I used to use back in college in 1994, a very old version of it, but it had something called the ports. And ports, if you've ever used Homebrew is the ability to install Unix applications on your Mac. The ports were that version. It was basically before Homebrew existed. There was something called the BSD ports, and it was the ability to have all these Unix commands that you can install on your Mac. And FreeBSD was very famous for being able to just really easily install cool commands and cool tools on your Mac or your PC, whatever you're running it on, without having to compile all the tools, which was how you used to have to do it in Solaris, which was a big pain in the butt. So that's what we did today. We went through, we got some threading code working here. Now, if we were to code review this, right? If I was technically code reviewing this, I'm not a fan of this right here, while true. This creates an infinite loop. And this is what great power becomes great responsibility. Jonathan Hubbard, thank you. Or Jordan Hubbard, thank you. This is Mac ports. Yes, he was super awesome. Very cool guy back in the early days. Just the history of that, if you ever get a chance to go look at it, it was just amazing. my first 7 years, I just had a Solaris box on my desk. And I went to Mac because the fact that it was a Unix platform that I could write all my code and just worked on it. And I could, get all my work done. But I also had Photoshop on my machine then. Solaris didn't have a Photoshop clone. So it was pretty cool back in the day. To look at this code, though, I'm not a fan of this while true, and I don't write this code that often. I recommend you do the same. There's a couple things that I highly hate. I hate infinite loops, and I hate go-to statements, unless you're writing assembler. If you're in C# or any other language like that, go-to statements are pretty evil, usually bad. They're against both object-oriented and functional programming concepts. Don't use them. Don't use infinite loops unless you have to, right? This is really because of the fact we have a worker, and we're just trying to keep the worker working, and there's no easy way to do this, because if you try to say, well, only when the queue is empty, run this, well, technically speaking, if the queue is empty, then this code will never run again, right? We need to keep this code running forever and let it sleep and then come back up. It's almost like if you're a game developer, we have something called the game loop, and the game loop is also an infinite loop that runs, and you're trying to get it to run, at 60 frames a second, which means you're trying to get this thing to run faster than 60 times a second in that loop, and that game loop is all about calculating all the things that needs a game work, and they would use something not like this but very similar in the game loop of in order to keep the engine running. For infinite amount of time, but then also you have to top out your pipeline and how you add things to the pipeline. I'm not a game developer to start out with. I know the concepts of game development because I've studied computer science and I understand the concepts of it, but by no means am I a game engine expert. I do understand the concepts of what they're trying to do, and the efficiencies of why they're trying to do things a certain way. Now, if we go back to this conversation, because what we're talking about here is we change this code out. Is this the right code for this? And the answer is no, it's not. Because, well, yes and no. Okay, to start out with, all I'm trying to do is a count. And in the grand scheme of things, I want my count to not run on the main UI thread. Okay, and that is, this code does that. It does it pretty well, but it's pretty hard to read. And if you don't know anything about threading, this code can look like magic. And you could go look up how threads work, right? In Swift's documentation, you could absolutely grab this. For your Cinnamore, you can go through, look at that code there. You can go even understand locking, what lock-in thread locking is. You could go Google all this stuff and find that out and figure it out. But it's not needed for reads, like I said. And since this is a realistic application, I don't want to keep this code. I want to keep this code for writes only. And so a couple hours ago, if you're on the stream, I talked about it. We were talking about embedded databases. What ends up happening is that you may need to have multiple connections open to the database to keep writes moving properly, but they have to be in the same thread. And that's why I built this worker, so that I could basically have control of the replicator I'm going to create much later that will be writing to the database, and also my UI that's going to be writing to the database. I want them to have two different database connections, be able to write to the database at the same time, and guarantee that they don't block each other, lock each other, all the bad things that happen, that transactions could continue to happen, and they can continue to write to the database. Now, this is thanks to some magic that SQLite does, but the secret is to this magic is that if you're going to do those multiple writes to the one file at the same time with two different connections open to that file, they have to be on the same thread. And we do not want them to be on the UI thread, because this will block the UI thread, I promise you. If you take replication in and you're trying to write 100 documents to the disk while you're taking a picture of a photo of some kind of thing in a warehouse and then saving that also to the database at the same time, if you try to do this without on the main thread, you're going to lock the application at some point in time. And the application is going to feel slow and sluggish to the end user. I don't want that. I want pure perfection of this. And since I've ran into this problem so many times, I already know the solution to it. So I'm going to write the solution so that I don't have the problem in the first place. So that's the conversation we started with today in the stream. And that's where we're going. So I know that the stream is almost done here, but I want to take a look real quick at this main actor stuff, right? So if we say, well, what's the solution to this problem then, Aaron, right? We got some homework to do, right? So there's a concept called main actors, and let's take a look here at Apple's docs for it. Let's see here. Well, we also have some blog articles here, but I don't. Well, so here's our friend Paul, right? And Paul's pretty awesome. So he's got a pretty good article about this. So main actor is a global actor that uses the main queue for executing work. So you can see here that the main actor runs on the main queue, which means it would run on the main thread, main UI thread. And then this is basically, he's saying, hey, this is, if you run it like this, you're going to have no problems whatsoever. You're always going to work and you're never going to have problems. You can see here that he's talking about the observable objects. These are parts of, the first time I saw observable objects is in Combine, but my understanding is now they're really just in the heart and soul of SwiftUI, part of the async framework. Someone correct me if I'm wrong on this, but my understanding is that really observable objects are beyond Combine these days, and they're really just using SwiftUI in general with async await and the new task framework. That's my understanding. Like I said, if I'm wrong on this, please someone correct me on that. You can see here, right here, you can see he's talking about here, like, we don't explicitly need to add a main actor, but there's some benefits to it. And so he's saying recommendation is simple. He's talking about our observable and our state objects. But what we want to do is we want to make a new actor. I was looking to see if he had any code examples in his. So right here, you can see right here is the annotation for it, right? This does lean on Combine. So this is a pass-through publisher. Yep. Okay, interesting. I wrote a blog article a couple years ago on Combine, and I have since not really kept up with the changes Apple's made until recently. I had worked on another project at work that was all Android based in Kotlin, so I had to get really deep into Jetpack Compose, and this is my first opportunity to step back out of Jetpack Compose land and go back to Swift land. The land where I started my mobile career is in Object-C, so I really have a big heart for iOS development specifically, and so it was kind of nice to go through and do these streams and kind of get back into it. So we can see here that he's annotating the class here with main actor, very much specifically saying that we want to do a task on the main actor and then do some kind of work here. So he's saying that you can make your own global actors here. So this article is basically just explaining what the main actor is. But what I want is, I think I want to have my own actor, and then a singleton actor who's is equivalent of the main dispatch queue. It's the main actor. So do we have some examples of making our own actor? Let's see. What's Paul have to say here on the conversation of actors? Going to read. I'm skimming this real quick here. So he's talking about bank accounts, but that's not giving me what I want either. Yeah, I don't know the syntax for the, I'm assuming that it's, I don't know the annotation syntax for it. Where is, see, all this is all main actor stuff. Okay. Let's look for the syntax of this. Modern concurrency. Global actor. So you just say actor, my actor, and then in here, which turns this into a singleton, right? When it comes down to it. Because the shared would be no difference in like your shared of it. Yep. Okay, so this actually, this article is really good. This is actually I like the pictures. You can see here that it's trying to explain, like, okay, we've got this actor called my actor, right? And we're going to say that this is shared, so it's like a singleton in some sense, right? If you think about it from that standpoint. And then you can just say my actor, here's a new function for it, right? You're attaching it onto your actor. And now when you look at it, we have all these things that my actor can do. That is pretty badass cool. I'm trying to think here. All my stuff's not isolated, so yes. Yeah, I didn't know that this is so this is the same website that boy, they're very famous back in the old days. NS Predicate, they had an article. If you had to use NS Predicate, for those that I know, I'm getting old school here again. That was a syntax that you had to have a link to it to remember. Like it's like regular expression. You just needed a link to it to remember the syntax for it. You do when not to use it as predicate, and it's super awesome. But they used to have a link that I have in my bookmarks somewhere that is like probably almost 10 years old, but it was like the gold standard I consider for NS Predicate. So I highly recommend their website. I did not know that this is the new version of their website. Oh yeah, look at this, the new web. Wow, huh. Well then, obviously this is a very well trusted source because of the fact that it is. I could tell you a bit, in prior years. They also had the, boy, I don't want to get nostalgic or anything, but back in the old days of UI Kit, there was something about, it had to do with heights, how we have set heights and cells, and this is in UI table view. And if you want to dynamically growing and shrinking cells, it turns out, and get performance out of this is way harder than you could possibly imagine it used to be. And to understand how this worked, they had the best article in the world. Nothing in Apple's documents could come to comparison of this article that talked about, like, how do you guarantee that I have different cell heights and guarantee that this thing will not only render properly, right, and the cells won't get cut off and not cut off. And this has to do with your labels, UI labels, whether or not you wanted them to be infinite sizes, or like most mobile apps, they'll just cut it off at 2 lines and say, hey, put 3 ellipses. I worked at a company where no, that had to be all the lines. If it was 3 lines, it needed to be 3 lines. If it was 6 lines, I need 6 lines, which means my height I could no longer calculate on my cell. So I had dynamic heights of cells. In iOS 7 and 8, believe it or not, this was actually kind of a nightmare if you didn't know what to do. And their article was the best blog article on the internet. Nothing in Apple's videos, nothing explained the way they did it. And I considered that the gold standard of how to figure out how to do dynamic heights in UI table view. And so if you're old school like me, I can tell you that this website earned its pedigree years ago with those kind of articles. So I trust everything on it. So you can see here we have a simple annotation that says my actor. We give it the class with my class name. At that point in time, that should give us our actor, as long as we make sure that, well, in the actor world, we have to make sure that we have a reference to self, right? So there's a static shared equals self, and that I believe would give us our singleton-like view of things. So in that world, what we'd want to do, let's go back here for a second. And we want to talk about, we have a repository. And so this is where our repository, we would want to make this into an actor instead of just a class by itself. And so we could call this, we don't want to call it mine. We don't want to call this warehouse actor, for example. Do I have to import anything for this to take effect? Let's see here. What did I do wrong? Oh, they defined it earlier. You have to say it's of type global actor. Yeah, so you would have to make and then you make a class from that, that's my understanding. So let's go through 1 second. Global actor, we would say, now this is actor, we'd say warehouse actor. And then in here, we'd have to just have a single thing that is, just reading this, we'd have to say static let self equal or shared equals self. Self like this, or self like this, self like this, and then I would just say warehouse actor this. Okay, what does it tell me to do? Convert self to can be reference to store initializer. Store property can be converted self type. Yeah, correct. That's the goal. I want to get rid of the queuing and all that kind of stuff, because the goal would be is that technically speaking, on reads, I don't care about all running on the same thread. And reads, you can run on whatever thread you want, just as long as it's not the main thread. And even technically speaking, you probably could. Let's just be honest. In the world of iPhone, Apple's processors are so powerful that I don't care who you are, what app you're writing, unless you're doing some pretty complicated stuff. This stuff's going to calculate way faster than you could possibly imagine. On Apple hardware, it's really good. If you're on a crappy Android phone, no, this is bad. You need to really think about all this a lot harder, because Android, there's a lot of bad stuff. Wait, what? Sorry. Let me go look at here what the docs say again. I'm sorry, I got explaining stuff and I got, so it should be warehouse. Okay, so I have warehouse actor. I'm looking at this article again. Sorry, I've got this off screen. So global actor, warehouse actor, according to this is right. And then you just do a static let shared equals self. So that's where the problem's coming in. Let's see. So it does not comply. Yes, fix. Wait, what? Why is it saying that I need an actor type in here? Yeah, I totally agree. But it's saying I don't fulfill the protocol for this, which would be the contract. Oh, you're saying, I see. You're saying just say, make a reference to yourself. So you're saying static let shared equal warehouse actor. Like this. And honestly, I probably could do this. I think you're right. So what I should do is say repository actor, and I can use this with all my repositories then, technically speaking. So, and so this would probably, I know that some people may start screaming at this, but I actually want to make a new file for this. Let's make a new file. We're going to call it Swift. I'm a separator kind of guy. I like my code to be separated out. So, because I'm going to have many repositories. So what I want to do is take this out like this, move it over here, bring it into here. Do I need Combine for this, or is Foundation going to be enough? Nope. Let's do here. So now we have this here. Let's go back to our warehouse repository over here. And now I can say this is repository actor instead. And so now if we take a look here, we are 2 hours into the stream, and now we, pardon, let's see here. You need no imports at all. Oh, that is refreshing, really. Swift just knows. Hell yeah. I'll rock with that any day of the week. All right, let's see here. So we have repository actors. Now that the actor's there, all of our repositories that do read could basically do this. It's part of standard library. That's very cool to know. STD lib stands for standard library. It's an old C term. There's standard lib. Let's see, with standard IO used to be STD IO. Constant IO, CON IO was for that. I think Windows used constant IO though. I don't remember. I don't tell you the truth. I don't know if I remember using constant IO in Solaris, but I do remember using constant IO all the freaking time on Windows. That turd. Okay, wow. Well, that makes sense, right? Because Swift is Object-C, technically speaking, right? It still does the Object-C stuff, so that makes sense. Very cool. I got to cough again. 1 second here. Let me mute. So we've now got this our actor stuff in play here. So technically speaking, our async code will continue to work here, but the difference is we don't necessarily need all this stuff. So what I want to do now is go backwards in time if we can. And the way we're going to go backwards in time is just go look and Git, because this stuff should be checked in. Let me go look at Git real quick here, and look at my code I had before I started today's stream. Let me go look at my repositories real quick here. We're going to go in here and find my code. We're going to go into source. We're then going to go into inventory. We're going to go find the data, our warehouse repository. And let's take a look at this. Our count method. Let's just bring this up here, copy this out, go back, and then we can compare and contract what we've done differently here. All right. So we look here. Let's actually get rid of this one. It was a fun lesson, but we don't necessarily actually undo. Let's go back for a second here. Let's comment this out. We'll need that code later. This is our example of how to do our enqueuing stuff when we go to do database writes. I did not know this, that you could just import Darwin or glibc. So glibc is for the GNU libraries. Is that correct? Man, that is... I did not know this at all. That is pretty bad. That's awesome, to tell you the truth. If that's true. Wow. Okay, that's... wow. GNU, boy. GNU stands for GNU is not Unix. By the way, GNU. It's kind of the heart soul of well, not the heart soul of Linux, but Linux itself is just a kernel, if you didn't know that. And then there's a distribution that runs on top of it, and then GNU is more of the utilities that kind of come with it in the frame of mind, really. If you come down to it, there's some pretty extreme thoughts in that world of, if you've been around a long time and had to watch the Linux battles of the early 2000s. If we go back here for a second here, this is our original count method. We can see here we had task, priority of background, weak self, all of this kind of stuff here. Technically speaking, this code, now we talked about it earlier actually, that we don't need, we have our reference to weak self here, but we technically speaking could just encapsulate these inside of our reference here instead, and save the hit on the unwrapping those. We're saying we could get rid of the task altogether. Really, so the actor code's going to handle, because this is an actor. Yeah, I'm going to have to fix some of this code. Give me a second here. I don't need this anymore, or this, because I can just talk to database manager execs directly. And let's find database manager here, and this would also be, so that's good. We need that, and then we need count key. So that's right. What's it matter about? Let's see here. can I call num function? What the heck did I screw up here? 1 second here. Let me take a look here. Oh, there's an if statement missing. Duh. I had to delete the if statement, folks. That's my bad. Because the database could be null. Because when we init the database, we're not really guaranteed that it could get created, technically speaking, in the database manager. If we go look here, we should have it defined, yeah. So you can see here that the inventory and the warehouse database should both be nullables. I probably shouldn't call those nullables, but I'm used to saying things for both Java and C# land. Those are nullables. Nullables, is that how they say it? I'm not sure how they say that in Swift land. But the theory would be is that they have the ability to be nil. And we have to unwrap those and get those back to where we know for a fact that this is not nil. And so that's what that's doing here. And this should all continue to work. So we should be able to, we did a 2-hour journey of threading conversations, but at the end, what we should be able to do is just click our, we're missing it. We got an extra, yeah, because we got rid of this here. This would be the close for the class. Let's do this, editor, structure reindent. That should fix our reindentation. I'm just keeping this count around for long enough for when I do my write code that I have the ability to have a cheat sheet for my coding. So let's go here and say build starts and works. That should work. And then let's go back to our test and make sure our test continues to run. This is the power of testing, folks. By the way, we just did a big journey of code changes, and we're able to see whether or not our code changes worked or not. So it's unknown. I bet you I didn't make this available to the test. 1 second here. Let me check. Yeah, give me a second here. Check that. So when you create a new file, you have to say what frameworks, what project can do it. And I forgot to check the test so that the tests know about that. Let's go ahead and run this again. But this is why I like tests so much. I know that, look, man, I've been there. Oh. Because I took this code out when we moved that over to threading. Let's go ahead and then get back to our tests again and try to run it now. And our test succeeded. So I know, man, a lot of people really hate writing tests. A lot of people really hate it. But let me show you the value that we just got out of that. We just changed a momentous amount of code. We tried out several ideas of how to do threading, like what's the most efficient way of handling threading. We talked about actors and figure out like how do we get our reads away from, different than writes, and guarantee that we can have our cake can eat it. And at the same time, though, all of our code, we were able to just run it to make sure that when we made all these changes that the end result was what we thought it should be. And that way, if anything were to break, like we had one point in time when I did the threading code where it wasn't working, when I had to reference the count wrong, right? And that test broke, and we were able to fix it. And so if you're new to development and you're watching the stream either on demand or you're watching right now live, this is why I write tests. It is plain simple. They only help me as a person, right? As I'm going through and trying to find the most efficient way to write certain things, they guarantee that I can guarantee the universe is done right. So how many tests should you write? Enough to guarantee that your code is cool, and that if you change your code, it's still cool. That's the answer. There is no answer to this. If your company says that you have to write 80% code coverage, then write your code to be 80% code coverage. If your company says 0 code coverage, you should still probably write some tests. I know that some people think they're a waste of time, but I think they're a way of a get out of jail free card. I can go through and play around with all this threading code and not have to worry about, did I break my core business logic? Does my app still work? So have you ever tried TCA? I have not tried it. The Swift composable, the composable architecture. Interesting. I'm reading. Oh, sorry. I should probably put this on stream so everybody can see what I'm looking at here. So this looks like it's a pattern or a framework for managing states in store. So this is starting to remind me, this is starting to look a lot like Redux. Okay. Yep. This is reminding me a lot of Redux. I mean, I'm already looking at reducers for state, which it is Redux. Okay, well, there we go. Okay, never mind. Answer. Oh, for those of you that may be React people, Redux is a pattern and a framework. Just so you understand that. Redux is a pattern. And people think that when I say Redux, they think I'm talking about React. Oh, you're talking React Native, or you're talking about being a JavaScript library? No. Redux is a pattern, folks, for state management, for functional programming, super popular, really interesting way to solve problems. A lot of times with reducers, we use a mathematical pattern called Thunk, which there is Thunk for React, React JS and React Native. In fact, there's a library called React Query in the React world, and that you basically makes so that you have to understand Thunk. Thunk is not all that complicated, if you ask me. It's all about slicers and reducers, but this is very, very interesting. I'm going to definitely take a look at this. I have a very large background in both React and Redux for various reasons. I'm not going to talk about today on the stream. Use the right tool for the right job is my answer. I do lead professionally. I lead a lot of front-end developers that write in web with React, and it's fine for what they are trying to use it for. I'm just scrolling through the document so I can see some of the syntax sugar that it's giving me here. This looks very cool. Wow. Very interesting. How many? Well, one, start this thing if you haven't yet, and watch it. I'm going to watch all activity. Anytime I like something, one, give them a star to start out with. Oh no! Wait, through J and I. Oh, what, you hate yourself? The Java native interface is a bridge between Java land and the native code. J and I is one of the hardest things that you can write in the world of Android. It is. No, there is no better solution for bridging. Not today. Well, if you want maximum flexibility, believe it or not, I'm actually probably right now I'm probably stronger in Android than I am Swift and iOS, to tell you the truth, just because I spent so much time over in Android land at work. There is no better way if you want to keep the compatibility that you're looking for, right? There's some people that if you're using pure Kotlin, you can have some different conversations. But your best bet, because of Android and amount of native code still out there running, or I shouldn't say native, that's a bad word. The amount of code still running in Java versus Kotlin is a conversation piece that you can have. And most people just remember, if you're on Android and you're using Kotlin, you're still using JVM, whether you like it or not. So, you know, you want to use Kotlin UI and Swift Core. KVM M for reverse. So Kotlin multi-machine, that's what KMM stands for, and that's something JetBrains has created, where you can basically write Kotlin code and then share it with your Swift app and have your Swift app use that business logic. Why would you want to do that? Well, I can tell you why you want to do that. Say, for example, you have a bunch of code that's really complicated. These repositories, for example, right? All these repository code that goes and gets information. Maybe it's not even from this embedded database. Maybe it's an API and stuff. If you have to do that in Android and iOS application, you're using native libraries. So you're writing in Swift and Kotlin or Java. You have to write that code twice. You have to keep track of all the data that's coming down, and maybe you have to write some custom business logic when you serialize the data and all that kind of stuff. You're writing that twice. Well, if you can find a way to share that code, that we'll call that your business logic code, right? Or your domain, depending on what programming patterns you're using or you want to talk about. If you can share that code between the two applications, so you have to write that again, then really each one of the applications only has a focus on one thing, is the UI, and you have this shared library that has all the business logic of how to get your information and how to bring it back out to the platform to display out. And that could save you some time and money when it comes down to it for coding. So That's not a bad thing, KMM. I would say right now, KMM, I looked at it for a project I'm working on, and it was pretty unstable. I should say I needed it to work on Mac specifically, not iOS. KMM and some of the stuff that they're doing with Kotlin, if you're just doing iPhone, it seems to be okay. I'm not going to poop on it, say that it's bad or good. I'm going to say that from what I tested on it with my POCs, it worked okay. But the second I went to Mac, oh geez, it was terrible. It was not good. It was pretty bad. And there's also another, there's also a Jetpack Compose that allows you to do multi-platform. So JCP multi-platform is Jetpack Compose, not JCP. So this is also another option out there for doing your UI, where you write your UI in Jetpack Compose, and you can run it on iOS, Android, your desktop, and web. This, I know with experience, it's terrible on Mac specifically. I literally did a POC on this. I pulled down the latest bits, and nothing is there for Mac desktop. Most of the components and controls simply have comments not implemented yet. And so I did a prototype of it because I literally wanted to use it for something, and it was bad, really bad. So this, I found that if you're doing iOS and Android, it's okay. It's not great. It's okay. But I would not use this. In fact, if I really had to, someone told me I could only write the code once, and I had to make it work on all the platforms and stuff, I'd probably go Flutter, to tell you the truth. And I'm just saying that I've got some experience with Flutter, and it's okay. You would never get the UI you're going to get out of a native application. Like UI split view is awesome. And that is the native experience. Let me make sure if I open this, I don't put any information that I don't want to show people. Let's see here. Let me show you what I'm talking about here real quick here before we end the stream. I'm going to have to end the stream soon, though, because I know that my wife is going to be mad because I have to cook supper yet tonight. Let's see here. But if we go here and find... So all of Apple's apps are based off of any of their modern apps where you talk about the notes, you talk about the tasks and stuff, are all based off of modern controls. And this is something called UI split view, where we have a column on the left and then another one on the right. This is two column split view. I say UI split view because that's the UI kit version of it. And as you probably have heard from here, I've done a lot of UI kit in my past, way more than SwiftUI. I still consider myself I'm barely above newbie level at SwiftUI. I know how to read it. I know how it works, but I have to look up syntax all the freaking time. But this is a pretty cool interface. As you can see here, it gives you some pop-ups and stuff. This is 2-column, but really the gold standard is 3-column. That's where you get into super cool stuff. And that's where, I know if I bring this up, I probably have some stuff in there I don't want to show on stream. Yeah, let's make sure that I don't have anything that I'm going to regret later. This is 3-column. I have a column here, a column here, a column here. This is UI split view or split view in SwiftUI. And this is the gold standard of how do you do cool things. And in Apple's UI, this could be the mail app. If you think about it, you have your mail folders, you have your list of messages, and then your message yourself. It is a pattern. It's a very popular pattern. Doing this in Flutter, extremely hard, because on iOS this will automatically collapse down and you'll just basically get the list of notes in the middle. When you click on it, you go right, and then it'll give you an icon automatically that will show you the menu over here, and that works automatically in iOS and iPad. You do no work for this. As long as you set up your split view right, you get massive awesomeness from the split view. It gives you this 3-column and it collapses down. Your navigation stack is magic. It's automatic. As long as you code it right, you're going to get free navigation between these 3 different layouts. And that is worth its weight in gold. No other platform does this. You can't do this in .NET. In Toolbar, exactly, right? You can't do this in .NET. Maui does not have a solution for this. You do not get a solution in Avalon or Uno on .NET. There's no Flutter solution for this. React Native is a nightmare. Go look at Facebook's app on an iPad, and you'll see that this does not even look native, because it's not. Because React Native is really optimized for iOS and not for iPad. There is no split view in React Native. It's a mess. If you have to do that 3-panel UI design and have it automatically work and stuff, not possible today in React Native. And this comes to what Jonas was saying earlier. If you want the best user experience and you want it to look native on that platform, you go to that platform and you write it. And that's the only way you're going to get it to look awesome. If you do any kind of cutting corners, you go to Flutter, you go to React Native, you go to .NET, you're going to cut corners. And your UI is going to have various things that doesn't look like it's there. It's meant to be there. Compared to Apple's native solutions and other native apps on that platform. Period. End of story. Of course, I'll caveat this out. This is just my opinion, but I promise you, if you go read on the internet, it's a popular opinion on the internet. I mean, this is why Swift still exists. Put it this way. If you could do all this stuff in a single code base, then Swift would not exist. And everybody would use whatever platform that was in order to do all that awesomeness. But it doesn't exist. And that's the reason why Swift still exists today. And that's why there's still a lot of developers using Swift and over on Android using things like Kotlin and Jetpack Compose, because on those platforms, it gives you a very native look and feel. And the code, while you're writing it twice, the user experience is better. And so it's worth the cost of writing the code twice, because you're getting the best user experience possible. I'll preface this all with saying that if you're writing line of business applications and you can make some caveat changes in the code where, you know, the business doesn't, the people that are paying for you to write the code don't necessarily care 100% about having it look perfect native, where you don't need the 3-column approach and stuff, then maybe you can get away with something like Flutter. And Flutter's really popular. React Native's really popular. You can be able to get away with Maui, which is on the .NET side. Any of those frameworks may work for you, right? But I can promise you, if you're looking for the pure awesomeness of the UI with things like UI split view and stuff, you need to be over on Swiftland. And over on Android, stick with Jetpack Compose. Their view system, the old XML-based system, that is the equivalent of UIKit over in Android. You could write in it. It's okay, but managing fragments and activities is not fun. Use Jetpack Compose if you can. It's pretty close to SwiftUI. Is it more mature than SwiftUI? Sort of. It's got its own set of problems. We'll just put it that way. They're different than SwiftUI's problems. I think Apple's done better with navigation. If you ask me, up to recently, navigation was pretty bad in SwiftUI. I came from navigation controllers and UIKit. Super easy, really awesome. Never once had problems with navigation. Navigation was easy peasy once you got used to how navigation controllers and stuff worked. But over in SwiftUI, when it first came out, navigation was a nightmare if you ask me. But that's gotten better recently. So, all right, folks, I'm going to end this stream here. I want to thank you all for hanging out with me on stuff. A couple things before I go. Discord, man. If you like to talk with developers like I do, you want to go over to Dev Club. Dev Club is a awesome Discord place that you can go chat with developers. Like-minded, they're super awesome. It's a very small community, but they have a SwiftUI place. Hang out here, man. It's awesome. I hang out there when I can. There's obviously for the Kotlin folks, there's a separate thing over there for Kotlin. I can't recommend this place enough. For like-minded nerds like us, it's a great place to hang out, ask questions, all those kind of things. Couchbase is a company I work for. They pay me so I can do these kind of things. If you are ever interested in a mobile database, you want to check out their Discord, go over to the mobile area. You'll obviously see me and a bunch of other people hanging out there, talking about things. I am biased all over there, and you'll see I have some recent posts here. Talked about Flutter with my friend Gabriel, who works on the Flutter version of our SDK. I'm going to have to go through and test that at work here in the next couple of days. But if you are interested in communities, you want to hang out, those are some cool places you can hang out. Now, usually I will try to see if any of my friends are online to raid. Let me see who is online right now, see if there's anybody that I have that is raid worthy. I don't see anybody here to raid right now. I can tell you this, my friends, I have a couple of friends that stream later on tonight. Your link is broken for Dev Club. I think it expired. Max is 7 days by default. I will fix that. I apologize for that. Dev Club is super awesome. I will get a new link out on Twitch for that. I apologize. But if you are, if you got some time later on tonight, or if you're looking for things to watch, I could tell you that. Let me go real quick here and look up a couple people here to tell you who to go watch. I think that they're super cool. So one, Nutter is pretty cool. Let me copy him into Nutterfy is pretty cool. Okay, cool, Jonas. Yeah, I was just in Europe for the last 18 days, so I wish I would have known that before. But yeah, I am in the Central Time Zone in the U.S., but am a big friend of Europe. In fact, my entire development team, except for me, is in Poland. So I talk with all the friends over across the pond all the time because pretty much everybody but me is in Poland or in Europe somewhere. My boss is in Germany, so I shouldn't say everybody's in Poland. But real quick here, if you go to my friends, I think here, I have a list of those on my schedule on Twitch, and that will give you some other people to go watch. Nutterfy is super awesome. Go watch him if you can. He's been doing a lot of cool things. CoPilot Swift is also a pretty cool guy. Go follow and watch him if you can. And Coco Types also is a pretty cool. So, all right, perfect. Dutch, nice. Well, Jonas, thanks for joining the stream, man. It really enjoyed you being on, and everybody else too. I know that some of the other regulars on here, and Matt, if you're still on, thank you also for joining. We're going to stream every week now, starting at noon at my time until 1, and that's going to be .NET only. It is going to be doing crazy things in .NET that nobody knows you can do, like write some Mac applications. So we're going to write real Mac applications with UIKit and Apple TV using C#, which is kind of bonkers. Nobody knows you can do that. I'll show you how to do that. Thursday, I return back again. We're going to continue working on these tests. We're going to actually get another query working. We're going to get another repository up and running. We should have, by the end of the next stream, because we already know our threading strategy for both read and writes now, we can crack out the query code really fast. So we should get all of our database tests and code written for queries, and then we'll start working on some UI on Friday. So Friday's stream will be out there. So I stream on Tuesdays, Thursdays, and Fridays. And then, like I said, daily during lunch, that is a separate stream that will be all .NET, not Swift, and we'll be doing crazy fun stuff with .NET. So follow if you like it. I will be hanging out on Discord, so if you have any questions for me, hang out there. Otherwise, y'all, keep safe. Be nice to one another, and just remember, we're all in this together, man. If you ever need anything, just contact me on Discord or on Twitter. If not, take care, and I look forward to seeing y'all on the next stream. Take care.